And good morning, good afternoon, and good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon, aka Luke, and I am a 3D printing variety streamer here on Twitch. What does that mean? Well, it means we do everything from unboxings like our X1C carbons and our Creality K1C to full-up printer builds like the Vorons here and the LH Stinger right here. We also take part in a lot of prototyping and beta testing, such as for Fadus hot ends, Trad Rack, the box turtle that everybody's familiar with. There's a couple of them right back here. And today we're going to be working on another beta build. This is going to be the RatRig Mill. This is a beta kit. And we'll be starting to assemble this. Now there is no assembly manual, so we're going to be going off straight CAD. And there will be changes between this kit and the production kits. How do I know this? I've gotten 3 different emails over the last week about changes that have already been identified, either shortfalls in the kit or changes primarily in different cable structures and stuff. So we're going to be working on the mechanical assembly of this. We're going to hold off on the electronics for now because there's going to be some, I don't have the spindle yet. The spindle is on order and is coming in, but there's been a delay and there's some other electronics changes that are going to occur. So we're going to work on building everything out mechanically, and then we'll add the electronics in at the end. So that's kind of the layout here. So let's start off with a good morning and welcome on in, Shrimp Father, Mr. Wizix, Chewy, how's it going? Good morning, Musaka, how's it going with you? Hope everybody's doing well. I've got a couple of cups of coffee here. We got that one, and then this one, our Black Rifle Coffee Company. The mug's got our Fur Missile, which is a homage to the canine working dog units of the military and first responders. And then I'm drinking my standard half and half in the other mug to keep me from getting too jittery. So Mrs. Dragon has just left for the morning Dunkin' runs. Morning, Bear Carhu, how are you? You're really in love with this ambrosia filament? Yes, yes. The ambrosia filament, the Midnight Meteorite that I used on the LH Stinger back here is gorgeous, and I'm pretty sure I just ordered like 4 more rolls last night. Either that or I had a dream that I was buying stuff on West 3D. I'm pretty sure I ordered 4 more rolls, as well as put down the deposit for the single run batch of CASA enclosure kits. If you're not familiar with CASA, CASA is the enclosure for the Millennium Machines Milo mini mill. So, yeah, so we've got that one that is, I haven't looked at the Galactic Grape just yet. I probably should have, but I think I just got more of the Ambrosia Midnight Meteorite because it's a gorgeous filament. So yeah, we're going to do several streams on this. I am off work the whole next week. I'm not sure how long my son's staying around, but next week there's probably going to be more than just the standard Tuesday, Thursday stream, just because it'll keep me busy and keep me from laying around all day and sleeping. So good morning, Shrimp Father. How are you doing? Oh, nice. The Galactic Grape. Sweet. So today we're going to get started on the RatRig the RatRig Mill. And what we're going to wind up doing is jumping back and forth a bit. So in the RatRig viewer, so this is you can see the words on stream sometimes. You can see that this allows me to do the exploded view and see some things in the assembly, where in Fusion I get to see the assembly, but I can't figure out how to do the exploded view on this assembly. So that's where I'll have to be going back and forth some between the two views. And also I'm going to start with just the Y assembly. Seriously, just the Y assembly? I'm bringing it all back. And we're going to start with just looking at the Y assembly, and we're going to start building this from the ground up. Now, we're going to build out the Y assembly, and as you can see here, you'll say, well, there's only 2 feet. Like, where's the other 2 feet? That is part of the Z tower. So we'll get our Y built out, and then we'll work on the Z tower. And when we do the Z tower, that's when we'll put on the 4 feet when we go ahead and get this line up. So my plan is we're going to start with Y, then we'll do Z. We'll mount those two together. We'll set it off the bench. We'll build X, and then we'll get X installed. Now I'm probably, once we start getting this done, we'll also have to look at the XY assembly and see how this mounts on. Now this is 2 plates. So we need to make sure that we're getting, I'll say, both of them mounted in the appropriate way when we get this installed here. So we'll start getting the Y assembly put together, and when we go to actually install the lead screw is when we'll start worrying about that joiner plate setup and how to get the joiner plate setup going. Yeah, so we'll kind of be switching back and forth between the two views because, once again, I know that there is a different weird type of bearing setup down here in this front plate. I'm sure there's a bearing setup back here in the rear plate. It's just not going to be real easy for me to see it here without doing a bunch of clicks out. And even these, normally like you would click on these and you would see the body plate name. I don't get a body plate name, which is going to get interesting because in our body plates, I get a, whoops, that was not the view I was expecting there. Hopefully this doesn't freeze on us. We get a lettering system that is not referenced in the CAD anywhere. So I'm literally going to have to be opening these up, looking at the plates, and just trying to match up plate to view is what we're going to wind up doing here. So it's going to make it a little bit of fun. We're going to have to do some lubing, right? Because we like to lube things on this stream. So we're going to have to lube our big rods on the stream here. I'm just trying to see if these are the same or not. And they look to be the same. So they're 2 straight up corner pieces. And this does look like it's going to be the base that we're going to be using here. So that does look like the right one. And you see there's this big thing of extrusions here. So we're going to have to open this up and then care for our extrusions over time. Now I'm hoping these are wrapped in subpacks to make it easier, which it appears that they are. Because this is the X plate. That's the 4060, or excuse me, 4160. These appear to be 4080s. So how's everybody doing today? Did everybody have a good Christmas? Some smaller pieces of 4120. I believe those are going to be for the Z-axis from the basic sizing of them. And it kind of feels like this one has oil all wrapped around it. Give me 1 second. I'm going to try and do this over here over the box so I don't get this shipping oil all over everything. I don't know why they would have oiled these things down, but it could also be that this is leaked oil from the MGN rails and the lead screws too. Just bear with me for a second, folks. I have no idea why they did that, but we get some paper towel down and you'll be able to see what I'm talking about there. And this could be leftover oil from the machining process. And it just wasn't cleaned off very well before it was packaged. I don't know. And I'm seeing a little bit of warp down in the grooves here. But look at that chunky beast. No, it didn't look like they cut them in a wrapper. It looks like they cut them though, and then this one may not have been cleaned off before it was wrapped. I don't know about the others. They could be just as oily. Yeah, they are just as oily. So, and here's the thing. The black sides won't corrode or anything. These cut sides have a potential for, let's put it this way. It's aluminum. It's not going to corrode, but it will oxidize. Once again, I don't know why they did that, but they did it. So here is our 4120, which is the extrusion that we're going to be using here. Yeah, 4120. we're going to have a couple of end pieces that go on here, and then we'll have our MGN rails that'll go on here. These are the MGN 15 by 420 millimeters. These are not 2060, these are 40 120. So 40 millimeters by 120. Yes, these things are big. In fact, when I go to put these end screws on, I hope that I have the right Allen keys up here. If not, I'm going to have to run down to the garage and get the ones out of the garage that I know that I have a bigger set on, because they're going to be huge, huge fasteners. And speaking of fasteners, let's see, we have the legs, or not the legs, but the feet. These are pretty big size feet, right? Going to give us a nice stable area. That's pretty nice. So I'll have the big feet. These will be the rear angle brackets. We won't need those just yet. And we'll start figuring things out. These are some cable connectors. These are 3-pin cable connector sets. Some heat sets, some other stuff. Some more cable connectors. Holy chunky bats. These are the jog knobs. Okay. Twelve by 8 by 1 millimeter shims. Extra parts. That's always good to know. There's the front corner brackets that we're not going to use just yet. They'll go over there with the feet section. These are the couplers, so we're going to need at least one of these. 4040 M3 nuts, we will be using these. Believe it or not, the whatchamacallit, our MGM rails are going on with M3 screws. 4040 M8 roll-in T-nuts. I'm just going to kind of lay everything out here. There's going to be the spacers to use to mount the motors. Lock collars, we'll need those. Some M8 locking hex nuts. Nut blocks for the 8mm TR8s. So we'll need those. M3 by 16 cap head screws. Those will be used to mount the whatchamacallit, the rails. Some hex inserts. Going to be a bunch of other small stuff, but hey, look, there's some M8 bolts, nice and oiled up. Some other M8, these are the M8 countersink, or excuse me, M12 25 countersinks. These are going to be putting our end plates on. And yeah, there's a lot of shipping oil or grease in these as well. I'm just going to try and get this stuff laid out so it's easier to look at and find when we start digging through. Because we will be digging through some stuff. And I know I had talked about, oh, I'll set these out in my bins. Brush washers. I know we're going to need to use those. Rail bearings, those are going to go over there. shipping oil. Have you had a chance to run the K1C? Yes. It's running right now. My brother, at Christmas time, asked for one of those spiral fidget cones. So this is one part printing here. I'll print the other part in another color. But yes, the K1C has been printing. I got another little dragon thing that I printed last night that's sitting downstairs. Good morning, Cruising Girl. Welcome on in. Now this kind of feels like a sub-assembly kit there, so we're just going to toss that over to the side. Oh wait, that was the locking collars, some shims, and these things are probably going to get used as well. These are connectors. Okay, so we've got the 4120 that we're going to need. We've got at least one of the end plates here that we're going to need. Let me go back over to the overhead view. We have at least one of the end plates, which would be the one where the motor is going to mount. And we'll need to find the other end plate on the other side, which looks more square rectangle-ish. Say this, the rectangle-ish longer ones are most likely going to be the ones for the x-axis, because those ones will be on the 160, the 40 by 160. So I'm going to say that is most likely the end plate we're going to use over here on the other side. There's our two end plates. And once again, these are pretty chunky beasts. Nicely countersunk before anodizing. And then here's going to be where all of our bearings and stuff are going to go. But as with anything, we need to get our rails on here first. And when we go to do the rails, we probably need to get our rails cleaned up, and I'm going to assume our rails are in the long wrapped piece here. Rails and some lead screws. There we go. Here's our Z lead screw, and then the X and the Y lead screws. So we'll set these aside for the time being. We will need to come back to these in a little bit, because we will be installing at least one of those today. Long and slightly shorter. I'm going to assume that since these are longer than the rail, that it's not these. So there are, great. There's at least 6 in here. So let's, I think there's 2 different sizes in this one. So right now mine is on the stock hot end still. I'm going to run it that way probably for the first month, and then in February we'll swap it over to the Fadus hot end that I was gifted. and we'll go from there. I have a feeling that really there's nothing that the Fadus hot end should, it doesn't add capabilities, okay? The hot ends on the X1C are already a stainless steel or hardened steel nozzle, so that's not going to provide any new capability that we don't already have with that we would get. It's just going to be the matter of more wear resistance and therefore reliability over time. There we go. But I do want to test out those Fadus hot ends since they sent them to me. And that was the onus for getting the printer to begin with. So these are longer rails. I'm going to assume that these are going to go on the x-axis, which is longer. These rails are going to be the ones that go on here, the 420s. So we'll take these two and set them aside with our lead screws for the time being. And these two will get unpacked and we'll check the grease on them. I'm going to assume that we're going to want to lubricate these appropriately. To ensure that they are fully and properly lubricated. These you would think would be set up in such a way that we can lubricate them after the fact with a Zerk fitting. We'll have to check out and see. Hey, Petty Ruxpin, welcome in. You've been experiencing hot ends. You've also seen exploding hot ends on the K1s. On the K1C or on the K1s? So the K1s have a different hot end style than the K1Cs. The K1Cs have like a fully integrated heat throat. So there's really shouldn't be any exploding or leakage around like a hot or a nozzle and a heat block. Good morning, Tugboat. How are you doing today? And these were definitely packed with shipping oil. And for now, I'm just going to wipe them down to try and get some of the excess off. I'm not going to wipe them down with alcohol. And once again, this is a light oil. This is not a grease or anything like that. Now there were some printed parts here. I do not know. I would assume that there might be some rail guides. This is going to be the top of the Z-axis. It's going to be another part there. Hey, 4120 MGN15s. There's our rail guide. I think there would be at least two of those. There'd be another printed part. 4120 MGN15. So there's our 2 rail guides there. Okay, so we've got our 2 rail guides that we'll use. We've got these. We're going to need to go ahead and lubricate these, and so let me see if I can get it over on this camera. So this side in the middle, you'll see there, or might be able to see there's a screw. You flip it to the other side and look at the other ends of these. There's no screw in the middle there. I should be able to grease these right through the end. I am going to use my standard EP2, though we can use the tube and our little plunger thing, but I am going to try and do it straight through here. Well, I see a bunch of goop around the end there, and I can't be guaranteed that anything went in, so we're going to do this the standard way. Slide these off the rail. We're going to grab our glove that I've had under here for a little while. Whoops. And we're going to lubricate this rail, or these carriages. I haven't seen Pez Liz in here yet. She normally likes to see these parts of the stream. All I'm going to do is put a bead right down on top of the ball bearings here. And then I'm going to push this down into the bearings and the races and push the bearings through a part of the cycle. And that'll move the grease down in there with them. And we'll rinse and repeat. Ah, the ceramic heater shatters, gotcha. Yeah, and the original K1s, like I said, did not have that heat break. They just had a nozzle. So a lot of times you're having to apply a little bit of pressure while you're trying to undo those nozzles. That, and people do not use a torque wrench all the time. So they over tighten them. And if you over tighten that ceramic, you will shatter it. Same thing with porcelain. That's why you have to be careful when you're securing your toilet seats and your toilets to the ground. Because if you're not careful, you can over tighten those bolts. And when you do, you'll crack and shatter the porcelain. And then you're just SOL. Now, one thing I do want to point out here is you notice that when I pulled these off to grease them, I had them laid in as they came off the rails in the direction and order that they came off the rails. And then as I did these, I pressed in, I turned them. So each time I pressed into one side, moved the bearings, turned it, did one side and stuff. So they were turned 90 degrees or 180 degrees. And then when I did the second bead, I turned them again. So that means they're back to their original orientation, as well as they're still in the right order. So when I go to slide them back onto the rails, they are in the same position they were in when they came off. And that will be good because of any preload tension that they had on here. You want these going in the same direction that they were in before. We're just running these through their races and most of the length, if not the full length. To make sure that that grease is getting through there well. And then any of the excess grease that comes, any of the excess grease that comes out on the rail edge there, we're going to lightly wipe it off. I'm not trying to get down into the groove because the groove is where we want the grease. I just want all the excess grease off the side rails where it's not going to do anything but collect dust and crud on these rails over time. Now, if you get your rails from China, we're not sure if these rails, these did not come from China, but if you get your rails, if you're self-sourcing and you get a bunch of your rails and hardened steel rods or whatever, if you're doing linear rods for your CNC build, and you're getting a cheap kit, it may say it's stainless steel. Don't trust that. What I do after I get these greased, if I bought rails from AliExpress or whatever, I grease them up, I wipe them down like you just saw, and after I get them put on, or right before, take a little bit of 3-in-1 oil and lightly wipe down, like just put some oil on a paper towel and wipe down the rails. That way you're getting a very light coat of oil on the rails, and that's a preventative measure to keep them from starting to rust if it's truly not stainless steel. Okay, so once again, we're going to pull these off. Put the rail down, put these down in the same order. I'll go ahead and grease this, turn it 180 degrees when I go to squish the grease in. And then do the same thing for the second round. That way they wind up in the same exact position, same orientation. Now, some people that are building CNCs from scratch and they're doing like full epoxy granite build tables and the whole 9 yards for them, they will tell you to take these things completely apart, flush them with mineral spirits or IPA to clean them out, maybe even run them through an ultrasonic cleaner after you've taken all the balls and everything out to make sure that you're getting everything out of them, and then grease them from scratch and rebuild them. You can do that. You can do that. And a lot of people will definitely tell you to do that if there was any evidence that these were shipped with a light oil in them, because oil and grease don't actually mix, and sometimes they can
actually interact with one another, depending on what was used when they were shipped. And I do not know if they're going to recommend that you take these apart in the final build manual, because like I said, right now I have no build manual. I'm just building this using the normal techniques. And I will tell you that here, this is going to be under a lot more load and weight than you would ever see on a 3D printer. So if they come out with a recommendation to break these down and grease them from the get-go, I would highly suggest that you do that in your build. Okay. Okay. Now I'll get these started. And so once again, that should be part of your routine maintenance on these, will be to go through and put a light coat of oil on your rails and actually all exposed metal surfaces to prevent rust. On a machine like this, you know, if you've ever watched any videos like Inheritance Machining, This Old Tony, you know, stuff like that, these things can get, well, over time, they're going to rust, right? It's steel. Steel will rust. And especially if you're running these things with like any type of misting or flood coolant, you're going to have, by definition, water or some type of moisture around your rails. So that will become part of your routine maintenance. Now, these are fully jammed up against one end of the rail itself. So, you know, I'm just going to leave that over there because we'll probably wind up using it later on. So there's one of two ways. We can just take our piece and put it right here to make sure that we're at the edge. We can go ahead and lightly put in a couple of the screws to make sure that it's nice and good and tight there. And I think that's what I'm going to do, is just for now put in a couple of screws there just to make sure that they're lightly held in place. And these are going to be the big flathead screws here. And once again, I don't know if you guys can see all the shipping oil and crap that's in here with these. So they always talk about, you know, they don't know if this is going to go on a plane or a boat, right? This stuff came from Portugal. It could come on a plane, it could come on a boat. So these are coated with a light oil for shipping to prevent them from rusting. And I am not sure if the biggest one I have here will actually fit in there. Not even close. So folks, bear with me for a moment. I'm going to run downstairs and grab my other set of Allen wrenches. And actually hold that thought. Did I leave the standard Allen wrench pack up here? No, I did not. Darn it. Okay, yeah. I'm going to have to run downstairs real fast to grab my other set of Allen wrenches. So I shall be back. I will keep you on this screen. I will mute the mic and I will be back momentarily. And I am still on the hunt because the ones I found were actually my SAE or American and not the metric ones. And I can't guarantee that these will work. Well, close enough. 5/8. So what I'm going to do is, once again, just lightly put 2 of these in, 1 on each side, so that we can get our rail lined up. I don't want to put this in all the way off the bat, just because I'm not sure like how I need to put the bearing stack and stuff in here for the when I go to put the whatchamacallit, when I go to put the lead screw in. And these would have to get thread lock on them at that point as well. But for right now, we're just going to get those lightly put in there. I believe we're going to wind up doing 1 T-nut for every single one of these. These stoppers are pretty in there. Hey, Iconic Fab, how's it going? How are you doing? And what we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to be using T-nuts, so T-nuts and M3x16 screws. And you say, well, how do you know they're M3x16? I looked at the other thing. So here they have screws. If you fully open up all the bodies in here, you can, do they have the screws listed out here? Slide down with the rails. Three by sixes at the end. There we go. M3x16 for all of these. So you're deep into the rabbit hole of designing a tool head. That sounds like fun. So all I'm going to do is hold this in and get our T-nut started. We'll do this all the way down. Now, if these were a standard T-nut, then we would just slide or roll them in and then line up our rail and go that way like we normally do. But these are hammerhead T-nuts, so we're going to have to get them all pre-done on here, and then we'll twist them and slide the whole thing in as one from this end. Once again, this is the RatRig mill. This is the beta kit for said mill. It uses 40 series extrusions, where like the Millennium Milo used 30 series. I used 40 series slot 8, which is the European style, in the black box build, and it is extremely robust extrusions. So I am expecting these to be very, very robust as well. Now you see me taking both stoppers off. You'd probably be better served by leaving at least one on until you're down to the end and can swap the last one out. That way, if you knock this off at any point, you don't knock your rails off, because if you do knock these off and you get your ball bearings out, it's going to be fun putting them back in. So at least on an MGN 15, they're going to be decent size. You know, when you're doing an MGN 7 rail, the ball bearings in them are flipping tiny. Thank you, Mrs. Dragon. And just, no, I meant to bring them up. Thank you. I was just looking for those actually. So just set it over there. You're fine. Push it back. There you go. Thank you, ma'am. 2 donuts? What kind? Okay. Blueberry and a jelly? Nice. Thank you.
Good?
Yep. So they didn't have donut holes at 10 a.m. Oh, okay. Gotcha. Yeah, so what I'm doing is building this from CAD. There is no instruction manual just yet. If you guys watched the last RatRig TV, you will see that they talked about the open beta on the mill and how they've already got feedback from several people that they've got people running the 1.5 and the 2.2 kilowatt in both 220 and 110 variations. And upon looking, I did realize that I did actually order the 2.2 kilowatt spindle from them. So I don't need to go and get one from KB3D, though it's going to be a while for that spindle to show up. They're stuck in, I think they said they're stuck in Kazakhstan right now. They offered me the ability to get a different spindle shipped directly to me from China, but it would have been the 1.5. And I'm like, well, since I paid for a 2.2, I might as well get the 2.2. So that's kind of where I'm at there. I will be waiting. I did have a thought of maybe I buy the KB3D one, because the other one could be a month or two. There may also be an issue with the rodent boards. Some of the rodent boards are having issues with Wi-Fi, and I think it's the RS438 protocol. Which is how it talks to the VFD. So with that, I may go through and get the 2.2 from KB3D, and potentially what I'll do is when I get the spindle from RatRig, I can swap it out and then take the one from KB3D and put on my Shapeoko to update my Shapeoko. I'm not tightening these down all the way. All I'm doing is tightening the N3x16 bolts enough that the carriages can slide back and forth. Basically so that the heads of the screws are beneath the rail itself. And normally what you would do would be you would get these lined up and as parallel as possible. And then you're going to use one as your parallel, and you would use the other one and you would use a dial test indicator and line up the other rail to be 100% parallel, both up and down and side to side with whichever rail you're calling your gold master for that axis. And that is exactly how you should be setting these up. It will take some time to do that. I am going to get these lined up here, like so. And here's the thing on these. You can start in the middle and work your way out, or start at an end and go out. I was about to start in the middle, but I think what I'm going to do on this, since this end is butted up against this metal piece, I'm going to start here and go down linearly. That way, any wave that I'm building in is going all the way down. The reason you do that is just so you don't build a hump into your rails. And that is your option. You can go from one end to the other, or go from the middle outward. And that way, as you're tightening it down, you're building a bow in it, and you're taking that bow out as you tighten it down. And what I'm doing here is just one at a time. Now, the other thought I just had was, do I go through and put Loctite on these? They're in hammerheads. You know, normally with your roll-ins, they're not going to move around. I probably should have put Loctite on every one of these before I put the hammerheads on. So that means I'm going to go through and add Loctite to them now before I tighten these down. And hopefully I don't have any issue with the hammerheads rolling around on me and out of place. So let me loosen these back up, because once again, I don't want to cause any up, down, ripple, or wave in this. And I was going to say, this is going to take a bit, so let me sit down. Oh, wait, I've got everything sitting on my stool here, so let me move a bunch of stuff off the stool. And like I said, when I ordered the beta kit, I did order it with the, I ordered it with the printed parts, so I didn't have to worry about printing the parts out. These are printed in, I believe they were ASA or ABS. You do have the option of printing your parts or reprinting your parts, however you want to do it. But for now, I'm going to pop these out one at a time. We'll put some Loctite on them and put them right back in. And once again, not tightening them down all the way. I'm just getting them so that the heads are underneath the rail itself. There's not that much printed parts on here, Chewy. Majority of it's going to be the metal plates that you see on the table here. Majority of them are going to be that. The couple of printed parts are going to be, I think, for the end stops, some cover plates. Even the electronics box is a metal box, unless you get the advanced electronics. So not a ton of printed parts here, no. Because once again, this is a heavier duty mill. Darn it. This is a heavier duty mill. So it's going to require a lot more rigidity. And you're going to get that rigidity from metal on metal, not metal on plastic. So like the top cap cover on the Z-axis will be plastic. We've actually seen that already. But the majority of the parts here in the frame that have to be rigid are going to be metal. It does two things. It adds to the weight of the machine, which is going to be good because you want that bulkier weight. It's going to help reduce the resonant frequencies and stuff. And you will see people that have taken the time to go through and fill their extrusions with epoxy granite. I am not going to be one of those. I talked to one of the guys that has one of these already out at Fabrico's booth. And he said he didn't see the need for the epoxy granite. Can you cut steel with this? Yes, you can. Are you going to be cutting a lot of steel with this? Not without flood cooling to keep the part cool so it doesn't work harden and snap off your bits. And I just don't think in this space and price point, you're going to have people that are using this for a large amount of steel. If you're going to do steel, you're going to go get a Tormach or something, right? This is for the home hobbyist machinist, prosumer type. My plan is going to be doing aluminum brackets on both this and the Milo. You can also do things like HDPE very easily on this, which will let you do various other plastics that you can use on your 3D printer builds, the mill itself. So this is really going to be doing upgrades for other projects on it and giving me the ability that I don't have in the Shape Poco or my laser. Hey Britt, how's it going? I saw you online the other day and I wanted to stop in and say hi, and I didn't. I've got family in town, so I didn't drop in. But as I said, my son's here this week, so I'm not going to do like a 9-hour stream today. We will stream somewhat. And then I believe he is taking off sometime this weekend or Monday. which means maybe we'll do some extra streams throughout the week since I'm off all next week. Yep, family first. I agree. Ugh. So what we're working on here, this is the RatRig Mill Beta. This is a beta kit. There are changes that are going to be, well, that are already anticipated in this kit. I've already got a couple of notifications. One was on the, did we just do this one, guys? Did we just do the one right after the rail alignment tool? I think we did. So there was a notice on the Rodent. So if you're running a VFD, then you would need to possibly get a different Rodent because the there was an issue with the Wi-Fi not staying on the Wi-Fi network, and the RS 435 or 438 protocol, which is what it uses to talk to the VFD, right? It's the serial, I believe that's the serial protocol. And I have sent in and said, yes, I'm using a VFD. They're going to send me a new board, but it may be a month or two. So we're going to somewhat build this, and then it's going to sit aside until we get the other parts that we need to finish the build. Because one, there's going to be the Rodent board issue, and then two, there's another issue that's been found with, I believe, some of the wiring and electronics. So they're going to have to send a couple of new cables over, which is no big deal. And I'm still waiting on my spindle, which, like I said, was delayed in Kazakhstan. RatRig's also announced the Rat Pack, which is a universal carbon and HEPA filter for the RatRig. And those go on sale January 7th. I will most likely order one of those. We've got the IDEX kit that we're going to be putting on the RatRig as well. And one of the reasons I'm starting this is to get some of the boxes out of the way of the corner over here, because the plan is to, we'll pull the black box out of the way so I have the ability to walk around the RatRig. We're going to wind up taking panels off the RatRig in order to do the IDEX upgrade to the RatRig more easily. Did I just do this one? So yeah, we're going to do the IDEX upgrade to that one. And that'll give us multi-material there. All the box turtles are built, and we're just trying to put some time on them. You have a PEI plate delayed by Canada Post. Strike is over, but they're catching up with, yeah, exactly. And I've got that package I need to get in the mail for you. I figured it wasn't necessary to jump right onto it, because with the Christmas season and with them just finishing their strike right as the Christmas season was hit, I figured it was just going to sit there anyhow. I was going to wait a couple of weeks and then get it going in the mail to you, Cruising Girl, because I don't want it to get lost in this package kerfuffle that they've got going on. Okay, so we've now got
Loctite on all of these. We'll make sure that they're pushed down tight. Okay, the first one's nudged. And just like I normally do, I'm going to go down one at a time and just get these snug, and then we'll come back and apply a little bit of elbow grease to them. And I'm just going to move this along every couple of holes just to make sure that we're keeping the spacing nice along the length. And this should, in theory, keep the spacing for these good end to end. And I have the dial test indicator out in the shed, so I'm not going to do the dial test indicator on these today. I'll have to come back and do it afterwards. And what I mean by dial test indicator is I will put a dial indicator mounted to one of the carriages and run it along. Once again, making like this, say this one will be my golden. I'll run it along this edge to make sure that side to side there's no waviness between this and the extrusion. So once I get that nice edge to edge, I will then hit along this top edge of the extrusion and make sure that it's not wavy this way. If I need to, I can add some shim material underneath it to make sure that it's straight this way. Once I get this in line and parallel to the side edge and the top edge of the extrusion, then I will come over and start running along this rail and get this rail, two things. One, equidistant this way, so I'll go against the side of the rail and I'll make sure that it's equidistant side to side, and do the same thing across the top. Hey Daisy, how's it going? Welcome in. Okay, so all these are tight. For now, I am going to go ahead and just give them a little bit of an ugga. I'm not even going to do an ugga-dugga, just a little bit of an ugga. Because once again, I'm going to need to make these things parallel down the road. And parallel 100%. The slightest deviation here is going to be noticeable in any part that you start to build on this. So that's why we're saying the more precision you put into building it at this stage, the better off your build's going to be, and the better off your end resulting parts are going to be. And one of the things is a lot of people will tell you don't build these things out of aluminum extrusion. And I'll explain to you why here in a second. Right? This is a known good flat surface. Right? Side to side here, I'm rock solid. Side to side here. So there is a twist in this extrusion. Even though it's a 40 by 120, there is twist. And your 2020s will get twists in it as well. Actually a lot easier because it's 2020. I'm doing good, Daisy. I will say there's also a little bit of burr on this from the cutting. So I'll probably take a file and just ease off these edges. I don't really care about these inside edges so much as just these bottom edges and the top edges, because that's going to be, you know, that's what's going to cause me some issues down the way as things get put together. So you do want to make sure to ease off any burrs off of these edges from the cuts. And once again, you can tell this was anodized and then cut, where the LDOs will be cut, finished, and then the whole thing anodized as one. So here's our Y-axis, Y-rail. I do have the plate on here for the moment. We do have some bearings and stuff that need to go in these plates, so I'm going to take this plate back off. I was just basically using it as a stop to make sure that these are all the way down at the end and good to go. So what I'm going to do is go ahead and take these back out. Once again, I only use 2 screws. And these are M12. Let's think about that. Even on the Rat Rig, I think we're using M6 bolts. These are M12 bolts that we're securing the end plates on with. So once again, these are some chunky boys. Let's see, we'll go back to the full display real fast. And so we've got our 2 rails mounted on here. We're going to need to, see, what are we going to start with? We'll start with this front edge, putting this front edge on. And then we'll have to get our motor mounted to the back plate here, get our connector on, and then we'll bring our bearings and all that good stuff in there from the end. I believe. So I'm trying to think to the Milo build and in the order of operations out of the Milo build, because once again, there's no real instruction manual just yet. So looking at our blow up, we just put in our rails. I'll say let's probably come down to this end and look at what we need to do for this end and mounting the first motor. Looks like we have some standoffs here. And the screws are going to go through, or the bolts are going to go through the motor, through the standoff, and into the rear plate. So these rear plates are, the rear plates here do have threaded holes. So those bolts are going to go through the motor, through the standoffs, and directly into this plate and bolt into the plate. Now, it looks like this side is getting a bearing, a washer, and a lock nut. And then the other side's getting a thrust bearing, and then the one of these. So these are the single couplers. So we're going to need a coupler. We're going to need a not seeing those. We're going to need the thrust bearings or standoffs. We'll need some of those. One motor, 4 standoffs. Nicely machined standoffs, by the way. We'll need a couple of the thrust bearings because there's going to be one on each side. There's 1, 2. And I think it's the 1281 shim that's going right here between the bearing and the locking collar. We're going to need one of these at this end, and there will be one at the other end. Memory serves me. We're going to need a couple of the locking collars and a couple of the ball bearings for the bearings. One of these for each side. Oh, not one, the locking collars. Be careful when you pull your locking collars out because they may or may not have the, in this case, they do not have the set screws in them that lock them. There is only one. So what I'm doing is I'm just getting everything out and looking at what I've got and what I'm going to need to use. So these are interesting. So I like that they're rigid, right? You've got the half split on each side, so that allows the clamping force. And we are clamping these with M3 screws. So they're clamping force. You're not putting a set screw on a lead screw, they're clamping around the rod end. And you'll notice that there's that center metal piece. That's the decoupling mechanism between the drive shaft and the actual lead screw. That's really cool. That is a really cool setup. So we'll have one of those, the motor. We'll have our rod. Just thinking about order of operations here. Because I know I want to do this side, and that's going to have to be slid in here. So we'll slide it in, or we'll build the end piece with the motor and everything. We'll mount it, and then we'll work on this side as we bring our rod in to mount this side. We're also going to have our block in here, so I'm going to have to look at the XY joint to figure out which blocks I need on here. Because this is not showing the rods or any of the blocking mechanism or the blocks, the XY joint itself. So what if I bring in the XY joint? Oops, sorry, I just realized that we're not showing you guys what I'm doing. So this is the XY joint, and it looks like there is a block fore and aft. This is one of the rails. These are the carriages that are going to mount to that underplate. And once again, there is two different blocks, which will be these blocks. They will get secured to the plates with nuts in them, so it comes down through the plate. M5 nut, which means that's going to be a M5 by 16 socket head bolt that goes through the top plate, goes through this, and the lead screw is going to come through here, and these are going to be, based on the two, are basically going to be your backlash set up between the two ends of that plate. So we're going to get things lined up. We're going to get things ready to go is what we're going to do. Okay. So I think I understand what all needs to be in play here. We're going to start with the end piece. And kind of build this setup in here. This is a plastic piece that's going to get added in. Move this around some and look at it from the front. Trying to look around and make sure I'm seeing all the bolts and stuff that we have. Where did those two bolts go into? Because the plastic piece here clips around the left side. All right, folks, I'm just trying to, I saw some M3 screws. I'm just trying to figure out where I'm seeing them and why. They're probably from that box up there. Not seeing them now. Okay, I think we're okay. I think I know what I need to do. So let's start with a motor, which is sitting over here in this box. And I'm not sure if I showed you guys these motors before, but these things are
chunky. So these are Nema 23 stepper motors. And they are chunky boys, right? Now, does it kind of show orientation of wires coming out to the right, not down? Those look like the wires right there coming out the right. And our screws. Go back to the main CAD for that. M5 by 50. M5 by 50. These bad boys here. Hey, Free Heathen, how's it going? Oh yeah, they could definitely hurt somebody, Cruising Girl. We're working on the RatRig Mill here, Free Heathen. And it's kind of interesting because we don't have a manual, so we're building straight from CAD. We've got our rails on there, and quite honestly, my rails have only been lined up using the printed jigs. So I don't want to go so far that I can't align the rails better. And what I mean by align the rails better is get the dial test indicator and take one of these off or move it to the side. Use the dial test indicator, mount it on here to test along the edge to make sure that I have side to side parallel with the extrusion. Then mount or adjust it so that it's riding right along the top of this edge here. And that's going to make sure that this is parallel to the extrusion from a top-down waviness. Then once I have this one where I want it properly shimmed and whatnot, then we'll make this rail 100% parallel side to side to this one, and then up and down to this one. That way when we mount everything, these rails are 100% parallel, and they're 100% parallel top to bottom, right? But the one thing we did notice, tiny bit of rocking there, a lot of rocking this way. So this left front, right rear, there's a lot of rocking. And that tells me that this 4120 extrusion has a twist in it. I'm not going to be able to fix that twist, right? I'm not going to get that twist out of this 4120. It's how it cools. So when they make extrusion, they take a aluminum billet, they heat it up, and then they run it through a press die, which creates this extrusion shape. And then it rolls out and cools. As it cools, they can twist. And that's why the longer extrusions you get, the more chance there's going to be a twist in it, just like a 2x4. But what we're going to try and do here is get these parts laid out so that we can get them connected. And I'm hoping, how is this going in there? I will lose access to the bottom nut or the bottom bolt here. So we're going to need to mount this on the back side at the very least before we get anything going. And also, the very least, before we get that going, I do want to deburr that bottom edge. Or actually, all of the edges slightly. Because once again, this was cut post-anodization. And I can tell that because the end, so there's anodized, that's not anodized. That tells me it was cut after it was anodized, and I had some burrs on the edge here. So I want to make sure that those burrs are removed prior to mounting anything to this edge, because that will give me the best chance to get a nice flat edge here along my quartz countertop piece. Now, Free Heathen, I know you're going to like this. So the Milo Mini Mill was 3060 extrusion, okay? Or 3030 series extrusion. This is 40 series extrusion. So this is 40 millimeters high, 120 wide. The X, the side to side here, is 40 by 160. Okay. Hey sis, how's it going? The bolts that we are using to put this in M5 by 25s. And then on the other side, we're using countersunk, or I'm sorry, not M5s, M12 by 25. Yeah. And they're sopping in shipping oil, so we'll have to... I'm wiping down at least the threads because we're going to put Loctite on them. Hey, Eagle the Dragon, how's it going, buddy? Eagle the Dragon, did you see the filament rack? We got the filament rack over here. This is all of my ABS. And I had bought another one that's going to go right here where the light is because I liked it so much. Whoops. There we go. And then Free Heathen. I want to say, I don't know about you, but I think these plates are pretty good grip on them. What does this look like, Free Heathen? Oh, no kidding. No kidding, Cruising Girl. One of the streams we may be doing this week, since I'm off all week, is building some of the stuff I've been printing out. I've got a Warhammer 40K bolter. And the part that I just showed you is actually a storm bolter. So I'll be putting a couple of those things together. I've also got the chain sword, but I've got to buy a bunch of stuff for the chain sword. But these are parts for the storm bolter. And so far the prints, these are being printed out on the Bamboo X1C. And the prints are coming out beautiful. Using the recommended, actually it's the 3MF files from the designer. So it's all got the pre-supports already baked in and everything. So that's been pretty nice. You've had to slather glue so you can get PLA prints off. Exactly. Sometimes people don't realize. They think glue is used as a bed adhesive. It's also used as a part release agent, right? You use the same thing if you're doing PET G on a smooth plate. You got to put glue on it. Otherwise, that PET G will fuse to your smooth PEI plate and rip it off. And welcome in, Nomi. How are you doing? Hope you're doing well. So once again, by doing this end plate on here, on the quartz, it's making sure that the bottom of this and the bottom of the extrusion is going to be flat together. We're going to be putting our M12 bolts, once again, M12 bolt, right? Let's do some comparison here. M12 by 25, M3 by 12. Slight difference. So M3 by 25 is going to be going into the back end here. It also looks, excuse me, M12 by 25. It also looks like there's going to be a washer on those. Just going to double check and see what washers I have to make sure I'm not using the wrong washers here. Ah. Those are M8. These are 12 by 8 shims. Truss bearings. No washers in there. Ah, there we go. And 12 black washers. Tired but moving around. Well, that's always good. I feel you on tired and moving around. We me and my son went and watched a couple of movies yesterday. And it was funny. Sitting at the house, I was about to fall asleep. Going to the movie theater, I was wide awake, which was weird. Once again, we're going to get some Loctite on our M12 washers here, or M12 bolts. And put our washer on it. And come right through the back. These are pre-drilled and tapped extrusions, which makes things nice. And the thread taps are pretty darn good based on what I'm feeling right here, because I'm able to pretty much run these all the way in by hand. So it's not like the taps are all messy and dirty, or the holes. Sometimes you'll get some holes and they'll tap them, but they won't even blow them out. Because normally what they'll do at the factory is they'll drill and tap these, and then they'll use compressed air and just blow out the holes. And that'll get any loose swarf out of them.
I'm just making sure that this feels centered side to side. And I don't think this is going to work. Nope. So it's bigger than a 5/8. I'm going to have to go and get some bigger wrenches, because there was no wrenches that came with this. And that's an M12 bolt. And I don't think I'm going to have anything that's M12 bolt head size. So this is going to be finger tight for right now. And I'll have to tighten these up after the fact, because I'm going to have to go out today and probably go to Harbor Freight and see if I can get a huge metric set. Yeah, dude, these are M12, and I think if I can find my T-handle wrenches, which I don't know where they're at. I'm looking around here. I'm not seeing them. I didn't see them out in the garage. Now, I did some cleaning up here, so I am able to see, like, there's one layer. And it was a set of T-handle Harbor Freight Allen keys. I'm just not seeing them here. But I think that only went up to a 10 millimeter. And these are M12 bolts. So, yeah, M12 bolts. Yeah. What I Yes, that is very true, Chewy. So what I should be doing here is looking for torque figures for an M12 bolt going metal to metal, because this is fastening metal to metal and should be torquing these down. Same thing is going to be going with these. We should be torquing all of our bolts down, because that's going to give us the best connection possible. So we're going to have this. We're going to have our coupler that'll come on there. We probably want to leave some type of gap between the motor and the coupler. And in fact, your motor shaft here, whoops, so if I show this, that motor shaft is past this metal centering ring. So you don't want that at all, because you need to decouple the two. So you want it somewhat close, but not completely. You want it close, but not into that ring area. So we're going to have to set up a gap here, tighten the lower bolt. Then when we put our 8 millimeter rod in here, we'll tighten the other bolt up against that. These are M3 screws. And this is, once again, a compression fit, but we are going to pop these out and put in some Loctite on these as well. And that's why I said, Free Heathen, that I haven't locked down like the rails yet, but everything on this machine, yes, should be should be torqued down, because once you get the machine built, some of the screws you're not going to be able to get to. And if you don't torque them down now and use Loctite on them, and you start hearing rattles later on, it's going to be a bad day. Because then you're going to have to clean everything up, take everything apart until you find the part that's rattling. Now, this does have a flat. We're compressing. It doesn't matter. The thing that's going to matter is just making sure, once again, that you're not bringing the shaft up to where the two will connect. You want it just beneath that that spacing washer.
Yeah, do the alignment and then torque. Okay. So we've got that done. We're going to have 4 bolts that are going to go through here. The bolts are going to have a spacer on them. And then they're going to go into this back plate. So you can see there's very little that's going to need to get Loctite on it. Let's take our Loctite stick and hit these threads. And these I should be able to do with a standard driver, 4mm driver. I'm only going to start with 2 screws right now. Get these lined up and get them in there loosely or fairly snug. And then we'll come in and do the other 2. Once again, I'm just getting them basically aligned and started into the piece because I'm going to need to get these aligned. And if you tighten them down, you're not going to be able to get the other ones in. The other piece that I'm going to need to look at, and these are going to be hand tightened because this motor is going to have to come back out. There's no way I'm going to get in there to get that center bolt if I don't. And once again, this is going to be assembled a couple of different times. We're going to put it together, take it apart, put it together, take it apart. That's going to be the nature of this beast. So not to worry. We could have put it in there dry, but there will be a plastic part that goes over this side as well. And looking at it, I'm not sure if I'll be able to fit it in the way it is right now. So when I take it back off, I'll put this plastic part right here on it. This plastic part is cable management, so no big deal. It's just a plastic part that loops over these 2 spacers on the side. So that's not going to be a big deal. We are going to need to put in our lead screw, and then we'll have to make sure that we get a locking nut on one side and other parts. Because once again, we're going to have a thrust washer. And then a bearing, a washer, and the locking collar when we put our rod in. Once again, that rod is going to have to be threaded through 2 of these that are going to be on the plate that's going to mount on these 4 carriages. And I really should line these up first before I mount this plate, which means I can't mount this on the, well, I can get this mounted on the plate, but I need to get these lined up. And the more I put on it now, the more I'm going to wind up having to take off. Preheating will get mad at me if I do what I think I'm going to do, which is just start building things up and then, like, do I align everything right off or not? So I believe the longer screw is the X-axis screw. The shorter one, of course, is going to be Z. And yeah, I'm pretty sure the middle screw is going to be the X-axis or the Y-axis. Let me see. Yes, this is actually slightly longer than the other one, so the middle screw is this one, middle length screw. So the long and the short will sit off to the side. I need to get my other plates out of here that I think are in here. Yep. So this has a slightly different mounting than the Milo. So the Milo had a single plate that you had your X and your Y rails into, which makes it very, very difficult to take the X and Y apart if you need to do things. Here, you have a separate plate that mounts to the X, and then a separate plate that mounts to the Y, and you will simply bolt these two together with some hefty bolts on the four corners. Now, I don't yet know if these are the same exact plates or not. One should have looked and seen if the part numbers were different before I did that, but is what it is. These are very well machined and nicely packaged. So yes, nicely machined and anodized plates. And they are drilled differently. So we are going to have to figure out which is which. Or are they drilled differently? Yes. They are definitely drilled to mount differently. So which one goes where? CAD. Aye, aye, aye. All right, so this is the top plate because it's got the extra M3 screws that are going along. Whoops, you guys are not seeing anything I'm talking about. I apologize. So this is going to be the top plate because it has the extra M3 screws along the side that are going to mount the guide there, those plastic guides, which means this is the bottom plate. This is going to be the one that's going to mount here. So what we'd be able to do is line this up, get it loosely mounted. But also we've got our two, 1 second, folks. Folks, give me 1 second. Sorry, it was my dad. And I love that they called to ask if their grandson is still here. I'm like, he's got a phone, call him. So this plate will mount here. Now, one of the things that I want you guys to notice is there's 2 holes here, and then there's 2 slots down here. The 2 holes are fixed. The slot will allow it to move forward and back in this, on this plate. And that is what is setting up your anti-backlash for this Z-axis, or for this Y-axis, right? Nothing here is stamped with numbers, so we're really just kind of going off of the CAD. So there is no, whatchamacallit, there is no manual for this just yet, Free Heathen. So that's why we're kind of working off the CAD. I believe we're going to use these M5 by 16. Where are we at here? Right. Ah! Yeah, M5 by 16 low head. These are the M5 by 16 low head. Actually, let me do these. So once again, 2 of these are going to be, I'll say, quote unquote, hard mounted. And then the other 2 are going to be able to be slid around. And that's so when you put your lead screw in, it'll actually be able to take out the backlash. Similar to using the springs with the nuts on them for your lead screw nuts. Now what I do want to look at is there are, on the bolts here, not the bolts but the nuts, are these, not the bolts. So those are locking nuts, so the M5 lock nuts. Preloading, yeah. So we do have, whoops, spots here for the lock nuts to actually drop down into. And, oh wow, they're a decently nice fit, press fit. And these are palm blocks. So these are things that we would be able to machine on a mill like this, right? So you can machine out, drill the hole through, because these are through holes, and then this is the lead screw. So I mean, possibility of doing these through here, but chances are you would not machine these. I think these are, well, I'm not sure how they would machine these. These are most likely like injection molded palm. And even on this top one, which is the static, I'm not going to tighten it down all the way. I want to keep it loose. And why? Because there is some play here, I can get an angle. So if I crank this down right now, it could induce an angle on this part. So what I'm going to do is get this in here somewhat loose, get this in there, obviously still somewhat loose. We'll get our lead screw when we mount it and run it through here. Then we'll tighten these up afterwards. And that way we ensure that that we're not bending the lead screw any more than it already may be when we're putting it into the machine. And because these are going into whatchamacallits, locking nuts, we don't have to put any Loctite or anything on these because that's the whole purpose of the locking nut. So those are on. We'd be able to go through and get these lined up and installed on the trucks. And we'll get these loosely installed, and then we'll use it to kind of align it back to back. I'm going to trust our printed jigs for now. I don't think I need, 5/10 precision on here, or even, super duper crazy tolerance on this just yet. We'll see. Like I said, I'll probably wind up tearing it apart and building it a couple of times. So please don't fret over me not going stupid crazy on aligning everything on this just yet. Well, I'll get this aligned and get this installed. Let me flip this over. Hold on. Hide that plate. M3x6 cap head screws. Thanks for the lurk, Westery. Stay out of trouble, sis. Once again, these are shipped with some packing oil in them, so all I'm trying to do here is just knock some of that off. 3, 4, 2.5 now. So I'm going to get all of these started. Not going to lock it all the way down. I'm just going to get them all started so I can make sure that I have alignment all the way across all 4 of these carts. And then we'll work on moving it up and down the rails to make sure that we have no binding. And then we'll go through and systematically tighten these down on all 4 trucks to make sure that we don't induce any binding along the way. So did I see you streaming earlier this morning, Free Heathen, or have you not, or was that last night that I saw you streaming? Again, I have not been on a lot of streams lately just because my wife and, well, my son's here, so we've been doing some family time stuff. And this would have been the son that lives out in the Goshen area, so Murph area. So you probably would have seen him out at Midwest Free Heathen. Can I come on Facecam for a minute? I can. Ah, Scary. What's up, my good sir? How's Miss Beans doing today? Oh, well, thank you, Free Heathen. I love you too, my dude. Love you too, my dude. Oh, that's all? Okay. Wanted to see my handsome good looks, huh? Now, I don't invent much. I build a bunch of stuff. I don't really invent much just yet, but it's coming. Okay. But like I said, I do take part in a lot of beta tests. This is inventing. Well, this is building somebody else's invention, but this is bringing something to life. So we are bringing something to life. And once again, one of the things that we could do to figure out if we're good or not will be to if we feel like we're binding it all on these, I could loosen up the screws on one rail and run this truck back and forth. And what that's going to do is align the one rail with the other rail. Now, up and down is still not going to be aligned per se, doing it that way, but we're going to align it side to side and we'll say skew to skew. But these are on light, and I'm going to move this side to side, being careful because I have no stops. So I want to move this to full length. And it's moving pretty easy. So I'm going to go through, not fully tightened. I'm just going to snug these down. And just do the big X pattern. And run it full length again. Still no bindings, so that's good. So we did the big X, and now we're going to come back and do the others. Once again, no torque, no ugga-duggas. We're just doing this down by hand, snugging them down by hand. And we're still running nice and parallel. So once again, this is where we should be going and torquing them down. Right now I'm using my torquing, elbow, forearm muscle there to make sure that I'm getting these about the same amount. And that's good. So we've got that down. It's moving pretty smoothly, so that's really nice. Let's see, what else do we want to work on? I will come back and torque these down before I go any further. I will torque down our T-nuts. I will torque down these before we go any further with adding more layers on here, and I stop losing access to a bunch of stuff. I am going to get my lead screw through here and kind of lined up, and then I will work on getting my bearings and stuff in on this side. The hard part's going to be getting the thrust washer in right here. And once again, that's where I'm probably going to take the motor back off, put the thrust washer on once I get everything set up. And because this is going to have to come off to torque these big bolts anyhow, and I'm going to have to get a bigger, I think I've got a good torque wrench. I'm going to need bigger bits for it. I do have a torque wrench for this. I bought that specifically when we built the, which one was it? Was it the VZ-Bot or the, I think it was the Annex Engineering K3. And the Annex Engineering K3 actually had a listing for torques for like the M3s going in, through metal into metal and stuff. I don't think they had M12, so we'll have to look up M12. And it's probably not going to be inch pounds. I mean, let's be honest. It's probably not going to be inch pounds. It may be something bigger than inch pounds there. So we'll have to work on that. Let me just see this bottom plate. We've got these bolts and we've got these two in. That's going to get us there for the most part. So I'm going to go ahead and bring this in, find our hole. There we go. And I'm threading it through this first palm nut, and we'll drive it through until it hits the second palm nut. Which it just got to the second palm nut. What I'm trying to do is find the distance where it will let me start to thread through the second palm nut. Probably should have flipped this whole thing around and gone in this one first and then come in through this one. Be a lot easier. I did not lube the screw. It's palm, so it should be self-lubricating. But I can add a little bit later when I start running it through its motions. And it looks like I'm going to pop this off now. And we'll run the screw through this side because 4 screws is a lot easier than 16. So you want to go through the end that has the that's straight first, or not straight, the non-moving side first. Where's your mag tray? Yeah. Probably be easier that way, wouldn't it? But I didn't want to take that off, but so be it. Hey, Glendon, how's it going? You're lazy, so am I. So am I. It's Hollywood. Go back to the overhead. You don't want to sit here and just stare at my belly the whole time. So we had our we had the end plate on slightly so that we could align our plates. We got align our rails to the end plate, which we got done. Then we popped that end plate back off. Got our end plate over here in so that we could get our motor mounted. Just had to take that off so that we could try to do the screw, and then we're taking this plate back off so we can actually get the screw on. Then we'll put the other plates back on, and along with our locking collars, bushings, thrust bearings, all that good stuff. So let's see if we can't get this started threading. Yeah. Good gracious. Things should not be directional, right? Oh, they're not directional. Or they're, yeah, they're not directional, but you do have to have them, we'll say, in alignment. Hey, R2 Builder, how's it going? Welcome on in. We're threading a rather large lead screw into a plate here. Making plans to take over the world? Gotcha. So on this particular plate, we've got one static and one that moves. They're not completely locked down just yet because we're going to have some things that we need to do. And we want to make sure that they're fully lined up down this channel before we go locking things in place. And part of what we're going to do is put this plate back on, make sure that it rotates up and down properly again, or slides up and down properly again. Then we'll need to add some bearings and stuff back on this side. So I'm putting these on loose to start with. And then we'll start locking them all back down. Spring roll. Are you referring to calipers, sir? Or are you saying I need like an abacus? My dial test indicator and my dial indicator are downstairs, outside in the shed. That is why I'm not using it to line everything up. Because technically what I should be doing is using that to make sure that these rails are perfectly straight, level, all that goodness, and parallel to one another. The downside that I have right now is, one, those aren't here, and then two, this 4120 I know is already, it's got a twist. It's got a twist. So I'm making sure that I've got good movement on the rails. And I'm doing a large crossing pattern to start with. Make sure I still have good movement full length. Then come back and do the other ones. We still got good movement, so we're good there. I'm going to go ahead and tighten this one down. So I really shouldn't just yet. Don't want to tighten this one down just yet. And that's because we're going to need to add some bearings and stuff to this end and figure out our correct length. So you'll see me going back and forth between the CAD So I'm going back and forth between the full CAD and the CAD section that I can get here, because I can explode this view out to get a better idea of what's where. So between the coupling, I have a thrush washer, a bearing, a washer, and then a locking collar. So I'm going to need to mount my motor again. You'll see we'll be putting this on, taking it off, putting it on, taking it off. It's all good. So what we're going to do is we're going to put the motor back on. Because we've got our locking collar in there, or our locking collar, our, whatchamacallit here. We're going to bring our lead screw all the way down to where it's going all the way through and touching. Okay? And we're going to back that back off because we need to install our bearing and stuff here. So we need our bearing, which is going to press fit. We'll have a washer and a locking collar. So let's get our locking collar ready. With any locking collar, you need to put some, thread locking compound on it. We're going to have a lock collar, a washer. We'll have that bearing, and then it's going to go in here. And what we're going to do is push this all the way in there. That now sets that washer right up against the edge, the lock collar. We're going to lock that collar down. Okay, and that gives us the locking at this point. So we know how deep this goes. And this is now shaft to shaft, right? Because this is a rigid coupler. I did not want to, yeah, it needs to be shaft to shaft. Okay? On a rigid coupler, it's shaft to shaft. And we're going to put a thrust bearing on this side, and then we'll lead these shafts together. So this may still move, but this is going to be our stop preventative measure. Because the way this works is thrust washer, this collar, shaft and motor. My brain just hurt. So, free heathen, this is a weird, like I can't tell, there's a metal piece right here because we're trying to push all the torque through, right? We've got a, where's the other one at? These are single couplers. And I've never seen these ones before. So you've got your half slit that makes the spring clamp for each side, right? And that's what makes the compressive clamp around the shaft and then around your lead screw. And then you've got the bearing surface in the middle. It almost looks like a bearing, but it's not. It's not the spring couplers. These very much look like I don't know. Yeah, this is bottoming out on that metal ring. So it's not bottoming out on the shaft. It's bottoming out on the metal ring. Looks like an offset spring coupler. Yeah, but there's a thrust bearing that goes between this, the coupler and the plate. Right, so we've got bearing internal, washer, and a lock nut. Sorry. So a bearing that's press fit in here with a washer and a lock nut. And then we have a thrust bearing. Now this thrust bearing, I don't think it's going to be that thick. And, oh, I already got a couple out. I don't think it winds up being that thick, and there's a decent gap there, so I may have to push the coupler a little bit further up there to make it fully fit. Because I'm assuming that the thrust bearing really should be pressed up against both surfaces here. So that's kind of where I was trying to get my initial distance. Well, that's actually going to be a decent fit. So now that I've got my thing there, I'm going to take the motor back off. Because this will let me get my thrust bearing on there. Yep, that was going to drop. That was a stupid thing to do, Luke. Ugh. Motor there. Now we'll need to add our thrush washer, which our thrush washer is, or thrush bearing is multiple pieces. So we've got a washer that has a flat edge and a grooved edge. So the bearing goes on those grooved edges. And the nice thing with a thrust bearing is it doesn't have just a straight shear load to it. So it's able to transfer that load down through the shaft. So it supports both what? Shear and, oh God, what's the opposite, or the other thing is sheared? Help me out here, free heathen. You know what I'm trying to get to. I do not have shims at the moment. What I will have push that as far forward as it will go. We're going to tighten these down. Okay, so this now is good. We've got our locking nut there as well. We're going to spin this around. And now we need to support this opposite end. And the opposite end will get a very similar treatment. Excuse me. Come back down here to the other side on our diagram. Yeah, axial would be the rotational. That's right. There you go, Chewy. So that's what a thrust washer does, is it does both the compression and the shear loading. So when we go to put on our other piece down here, it's a locking collar, a washer, and an embedded bearing. So we'll have to put a locking collar and a washer on here. So we'll get our locking collar set up. A little bit of thread locker. Slide that locking collar on here. We got a locking collar, a washer, excuse me, a shim. We'll have a bearing that gets press fit into the end there. That will slide on. We're going to mount our M12 flathead screws here. With some Loctite. And once again, I'll have to come back and torque all of these down to their appropriate torque values. Need one more of these. Yeah, axial will be rotational load. With these being countersunk, they should self-align this front panel. Okay, so once again, we've got our bearing, which popped out of its spot. Get back in there. We'll have our washer and lock nut. We'll just pull those straight up and until they're flush up against there. We'll go ahead and lock down our locking collar. Locking it, that set screw is locking against the threads of our threaded rod. We'll have another thrust bearing. So once again, you'll have a flush side and then a bearing side. Whoops, a bearing side. The bearing will roll in there. Put the other bearing side in there. And that whole sandwich will go right on the end. And now we're going to have one of our big jog knob, which is basically a huge frickin' T-nut or lead screw T-nut, basically is what this is. Let me go to the bench side view. So we're going to have two locking set screws in here, and then we'll have a place that we can put a handle, and this is knurled, so you can use this straight by hand to move your plate around. So we'll need to get a couple of our set screws. And some Loctite. Well, I may have to order some more Loctite after this build. Or soon for this build. Get our two screws ready. I'm going to push this up against to set in some preload on those thrust washers and bearing. And there you go. We're moving our build plate by hand. Now, once again, this is not fully tightened down yet, so I still need to tighten this down. I wanted to make sure that I had full range of motion going here before I tightened anything down. And I do. So I'm going to tighten the back pieces first. Because once again, this is my static, non-moving side. And this would be the backlash side. And what you're trying to do is you want to make sure that you don't have a lot of movement before it actually starts travel. So you want it to be instantaneous when you go from one side to the other without any binding. So it looks like we're actually pretty good right there. So when I change direction, it starts moving. And we're moving smoothly through this whole thing. Now I don't know, there are 4 screw holes, threaded screw holes in here. And once again, this is a standard locking nut that they have just knurled the edges on. It would be very easy to build a handle and a shoulder bolt screw here, and we could use the handle to jog versus doing it by hand holding that wheel. Doing the handle might be easier than doing it by the wheel here. But at this point, we've got a y-axis, folks. That is our y-axis. We've got our lead screw installed. We've got the motor installed. We still need to torque down the end plates. And let me close this up. 2.5, 3, 4. And torquing this side, I've got free access. Torquing this side, I'm not going to be able to get to this bolt without taking the motor back off. So I'll have to take the motor back off, which is just loosening the one screw on the lead screw. Taking these 4 bolts out, we'll pull the motor off. I'll torque these down. Then we can put the motor back on. We'll have to torque these bolts down. And we should be pretty good. We can torque these down. We've got Loctite on them. As you're torquing these down, be careful. Okay? Be careful, because if you torque these down, one, you can bend the extrusions and deform the extrusions, and then you're going to start getting binding along the length. So I probably won't torque these down any more than what I did by, you know, the forearm torque method. But we've got real smooth movement here. There's zero binding whatsoever. And to get lead screws this long that have not been bent anywhere in shipping is crazy. That's awesome. We'll need to build the X plate as well. I think what I wanted to do, though, is build the Z up. Because once I get the Z up, then I'll be able to add the side corner triangles, and we'll be able to get it up on its feet. It's 1 o'clock. Let's see, what do we want to do? Let's assemble everything again. Get it back into view. Properties. We've got the Y done, and it looks like there is a handle here. So it looks like there is a handle. Let's
See if we can't find that handle piece. I wonder if it's just another one of these. So, nope, those are 3 motor standoffs. Could be a printed part. Well, there's not to be a printed part in the bag. Once again, this piece right here will clip over this side. So looks like it, yeah, we'll slip it on once we take the motor off. The next time we'll slip this on, but this is going to be a mount for the, actually this is, looks like zip tie slots for zip tying cables. So we'll see where the, we'll figure out where the knob is. I really don't want to add it right now anyhow because it's something else I can catch. Hey, off axis, how's it going? So we've got our y-axis built. I need to torque some bolts down, especially these end bolts. Probably want to torque these down to spec on the carriages. These, no need to. They're the T-nut blocks here. They're palm nuts. We'll have to take the motor off to torque the end bolts on because I can't get to this bolt. This is an M12 socket head bolt. These things are massive. So we're going to need to do some work still. So we'll take the motor off. We'll torque the end plate bolts. We'll put the motor back on. We'll torque those motor mounts. And then we'll be pretty much calling this done for the assembly here. We're going to go ahead and work on the Z assembly next. So we'll come in here for the browser. We will turn off that one and we'll turn on the Z tower. Yes. So this is the part that we're going to be doing next is the Z tower. And this is where we're going to start getting into a couple of other pieces. So it looks like 2 sets of uprights. Going to basically make a C channel around there. And a metric butt ton of screws again. Man, that looks like fun, doesn't it? Oh, you can't see it. I'm sorry, you're looking at my belly again. So we're going to start working on the Z pillar. We've got the 2 vertical uprights. This looks like 40/80. It's going to get the plates here on each side. We'll have the 41/20s. The 2 short ones here that make up the front edge of this. Yeah, that's going to be fun to put together. Just because it's a bunch of screws and all of those screws are using hammerhead T-nuts. Yay. So we're going to take this off the bench and we'll set it over here on the side. We'll put it on the ground, preferably in a place where we don't trip over it. We're going to need our 2 big plates. You can stay there. We're going to need our 2 big plates.
Did a pretty good job of keeping everything wrapped up. You're a T-nut? Yeah. Hey, like I said, that's the reason why we're starting some of this build now, is to get this out of the way, or at least get it in parts that can be moved and squirreled out of the way. We will be doing the RatRig update to an IDEX soon. And then we'll also be doing a couple of other projects. So like one of the other things that we're going to do is bring over the X1C, or one of them, and do a lot of upgrades to the X1C. So we're going to jump back over to CAD. We're going to hide the Y, hide that joiner plate, bring the Z tower into view. And what do we have here bolt-wise? M8 by 18 and M8 washers. M8 by 18 and M8 washers. M8 by 25. These are the simple M8 washers. Could be a big bag of M8 by 18. How much you want to bet these are the M8 by 18s? Since there's obviously going to be a huge amount of them, pretty sure that be them. Okay, and what I'm going to do is I'm going to go ahead and get both of these plates set up. Luckily, I'm looking at them. There's some M3s down here that will be for an end stop. They're both milled just the same way, so it's not going to matter. 4040 M3s. My M8 T-nuts are right here. So basically what we're going to do is get both of these set up, and then we'll put in the one rail. This large upright rail here, we'll do these two, because that'll take up most of this side, and then we'll come back and play with the rest. So we need one of these, a washer, and then the T-nut in every hole up and down the long side of these. Let's flip this around so you get at least a bigger view of what I'm doing and a smaller view possibly of the CAD. So my goal here is to get the side plates and the main upright going. And then we'll come through and be able to join this to the bottom plate. And here's a thought, should I be putting Loctite on these? Probably. I mean, there's only like 50 million of them. I mean, you don't want to be going around trying to figure out which one of these is loose, that's for sure. And a machine like this running a 2.2 kilowatt spindle is going to generate some vibration. Prep all screws first, then insert them. You don't like the hammer test? Yeah, if these were using roll-in T-nuts, then I would set all the T-nuts in place like we did on the Milo. I would set all the T-nuts in place and then go through, line them up, and then go do stuff. Or get them lined up, and then I would do the screws with Loctite and insert them. Because these are hammerheads, I mean, we did wind up making the decision to put Loctite on the MGN rails after the fact, so we had to take them out one by one and Loctite them and put them back in. Now here's the danger of that. Because these are using hammerhead T-nuts, when you take them out, that hammerhead T-nut could fall out of position and may not go back on there nicely. So doing it at this stage is the best time to put Loctite on your hammerhead T-nuts. So darn it. Hey Bexy, how's it going? Are there any through bolts on this? The through bolts on this are going into the ends of the extrusion. So the ones that went through the end plate into the like the end plate mounts into the extrusions are through bolts. You're not seeing the app, so let me bring up the application here. Whoops. So these bolts right here at the top on this top plate are going to go through the plastic into the extrusion. So these 4 top bolts will be through bolts, right? But it looks like for assembly reasons, and I will probably say maintenance reasons is what I'm thinking here, these are hammerhead bolts versus through bolts because we're going into extrusion. If you were going into steel, then chances are you would have lined up, drilled, and tapped the steel. In fact, some of the things I have seen people do is make a steel channel now. Once you have your CNC mill set up, right, you can mill your own steel
and make your upgrade parts, because you're going to want precision milled steel parts that are properly drilled and tapped, and then you can take this apart, and then you're basically going to be threading directly back into the steel versus doing the blind nuts or the blind nuts or the hammerheads. And that's where like your Tormachs are going into steel beams, right? And those are pre-drilled beams. So you're basically screwing into the steel, and you get better alignment that way. Yeah, so a lot of times, like technically the Milo, right? The full metal jacket, which is basically what this is on the, having the full metal side panels. Normally these would be put together with printed parts, and then you would mill these out yourself. And then, speaking of coffee, hold on, let me grab the coffee. So normally what you would do is put this together with printed parts, and then you would mill these plates out yourself on the printer or on the mill. You would do your, basically mill out all of your end plates and then build it. And that's a more cost-effective way of doing it, because rather than buying all the pre-CNC'd parts, you would print out the parts, put your machine together, CNC the necessary parts, and that way you're learning the CNC and CNCing your parts to do your first batch of upgrades. And in fact, the Milo, I think, what do they call it? Ironheart is, so I've got 3D printed spindle mount for the Milo right now. The first thing I'm going to do is print out the CNC spindle mounts and then print out the new parts, because the new printed parts at that point are cosmetic. They're not actually holding the spindle in place. They're just cosmetically going over the metal rings that are now holding the spindle in place. Right, so that's one of the first upgrades that you can do. And then also a lot of people start milling out like hold down clamps and stuff, which is pretty standard for a mill. Even on the Shape Oko, one of the first things that you cut out on the Shape Oko is going to be clamps to then clamp stuff down. Okay, so at least one of these lower ones, if not two of these lower outer ones, I think, go for the, yeah, these bottom two outer ones will be used to hold the, whatchamacallit in place, as well as the lower one are the ones that join to the lower frame. So I may hold off on those for right now, because we're not going to need those. We'll be able to slide these in place. Okay, so I'm going to go just that far for right now, and we'll do the rest as we need to. And I need to make sure that these are in opposite directions and not facing the same way. Otherwise, I'm going to have a very, very bad day when I have to go through and redo every single one of them on one side,
because remember, these are opposite sides. So one going this way, one coming that way. So they have to be going in opposite directions. Anything, yeah. So we've got the RatRig VCore 4 sitting right off to my left. We have the IDEX upgrade for that on hand now, so we will be doing the IDEX upgrade to that soon, like probably this next week. But we'll see. I need to basically get a lot of the boxes off the floor there so I can basically get to where I can move the black box out of the way and have full access all the way around the machine. Because even though it's a 300 size, that RatRig is not a one-man lift and move. And for those that are building the 500, it's pretty much build it where you're going to put it because you're not moving it very easily. And it's definitely not leaving through a normal door. So yes, Bexy Beans, coffee. Thank you. I need a break and some water. I agree. I do need some water. I may take a break here and go downstairs, grab some water, stretch my legs, maybe grab a bite of a donut real fast or something more substantial. So let me finish off the screws that I have here, and then I'll go down and grab some water, take a short break. Yeah, the A1s, I've seen great things with the A1 and the A1 Mini. I'm running the Bamboo X1C, and you know, it works great. We're currently printing with the K1C, right? And I don't really want to. So I have several big printers. I don't need a bigger printer just yet. I say that, but I do have a project that will require a bigger printer, but it's going to be a 500 or 600 size. So at that point, I'm either going to build a RatRig 500 or I'm going to build like a StableBot, which I can get in a 600 size, which I kind of like that idea. I just need to look at the cost benefit ratio a little bit. Okay. I'm not going to put any more of the screws out. I'm just going to put some more of those out. I'm going to get the last 2 screws put in, and then I'm going to take my break. Just a short break to go downstairs, grab some water, because I'm drinking a lot of coffee. I need to get some water in me. Maybe a quick snack, wash my hands. All right. And because of Free Heathen, not in a bad way, but because Free Heathen reminded me, I am going to go downstairs. I'm going to grab some water. So I'm going to take a quick break, grab some water, you know, do the necessary. Hey, Britt, how's it going? Yeah, yet. Let me check chat out real fast.
Yeah, it's been a while off axis. You're off work on disability for probably forever. Oh no. Um, hey, you can do manual machining on these things as well. You really can. Um, yeah, this is a RatRig mill. We've already got the Milo mill. I still need to go and do the software install and stuff on the Milo mill, but it's out in the shed because I don't have access to a 20 amp circuit up here in the office. So it's got to either go in the shed where I have 20 amps, or I need to get some, well, and I need to get some 20 amps down in the garage as well. The black box, I actually have not been doing too much with it. I need to get it going and, well, need to get it up and running because for the KB3D Death Racer, we're going to be doing some multi-material and some multicolor, especially like TPU stuff that we're going to need something like that that we can direct drive in. So checking, check. Yep. Hey, Da Vinci, how's it going? How you doing? Hey, Off Axis, thank you for subscribing. I appreciate that. Pez Liz popping in with 101 bits. Good morning, Liz. Coffee to you. I'm going to pop over here, give you a quick cheers with some coffee. And now I'm going to take a very quick break. I'm going to run downstairs. I'm going to put you guys on mute. I'm going to run downstairs, wash my hands, grab some coffee and a quick bite of something real fast because I've been going for a little while here. Just need a little bit of sustenance. And I will be back in 3 to 5 minutes. And we'll continue with the build. We are building on the RatRig mill today. So just trying to get something else built and some of the boxes off the floor again to make some room, to make it safer for me as I move things around in the shop. And from the looks of it, by the time I get back, the print that's going on over here on the K1C should be done. And we'll be able to do a color swap and get the second piece of this going. Well, that was a straight lead screw before I knocked it off the bench. We'll put that over here so it can stay straight. And like I said, I will be back momentarily. I'm not going to do the be right back screen because I don't think the drop game works on be right back. Drop game should work on this screen. Let's do a quick check. Yep, drop game works here. So please chat amongst yourself and feel free to do some drops. I will be back in just a couple of minutes. a free heathen. For the Emperor and Sanguinius. Okay. We'll sit back down here. We'll get going on the browser window. I did grab a big bottle of water. Thank you everybody for hanging around. And Liz, how are you doing today? Are you still traveling and away from home? Need as many more of these, but we will try and get some, at least somewhat, cleaned off of their shipping oil. Okay, so still with the family until Monday night. Gotcha. 2, 4, 6. We'll use those, but in a short bit. I have a feeling I'm going to need another one of these Loctite sticks here soon. I don't think I have an extra one just yet, so I might have to get a couple on order. Darn it. Sorry about that loud noise, folks. I'm sure that was right in your ear, as it was in mine. Well, I hope that everybody had a good holiday and is set up for a happy new year. It's going to be a good new year. I am going to be setting up a Streamiversary stream on January 18th, because the following Saturday I will not be able to stream because I'm doing an all-day charity event down at the local gaming store and will not be around that day. But the 18th, I'm going to set up and do my Streamiversary stream. I will be streaming for 2 years. And yeah, we're going to have several prizes. I'm trying to reach out to various vendors right now to try and get them to respond back shortly after the first of the year. I'm not expecting anybody between Christmas and New Year's to respond, but we'll see. I do have a couple of things already that I will be tossing into the kitty, so to speak, for the giveaways.
And let's see. I don't want to get into specifics just yet until I get everything going, but there will be a couple of printers and stuff. So definitely put on your calendars the Saturday stream on the 18th. We're going to have some fun. Okay, so we've got that. We need our two, I believe these are going to be the taller, longer pieces of our 4080. In fact, it's our only 4080, which makes it very simple. And once again, there is a ton, and I just realized that my overhead camera has failed me again. So we'll switch over to the tripod. I don't know if it's just like overheating or what, but there is a ton of shipping lubricant in here. Which is just like, ugh. And I just cleaned my hands, so. Where's the other edge at? We're going to be back to doing this. That down. Good. Get some IPA going and wipe these down some. Going to run into the same issue with the other one, I'm sure. Yep. Now, I don't know if they were shipping these out like on a boat, I would assume. Because if you were shipping via air, I don't think they would have had to or felt the need to put this much, like, I'll say shipping oil on things. Just kind of feels a little excessive. Probably should have started opening these with gloves on, is how much moisture and crap's on them, but okay. We'll need more down the road as we get into them, but for now, let's see if we can't get these kind of lined up horizontally. There we go. And it's going to be flush with the top here. So I'm going to use a 1, 2, 3 block to just try and keep it flush at the top. And we'll try and get it flush at the back as well. Larger than a 4, smaller than a 5/16. Let's see if the quarter fits. Okay. Quarter doesn't fit appropriately. This one does. And I'm making sure that these are rotating in there as hammerhead nuts should. Once again, I've got it flush at the top. I'm trying to make sure it's flush at the side as well. And you see me unloosen these some, and basically what I'm doing there is just making sure that it's not too tight so it has the ability to do the twist and the extrusion. If they're already too tight on the they're already too tight in the channel, they won't turn. They need to make sure and give them that little bit of room that they need to do the actual turn and twist in the extrusion. Hopefully I didn't lose everybody. That got quiet. Yeah, probably off axis. It's just a good one to have there with the drop game. You could pick one printer to rule them all, and you could only take one with you into the next world. What would you pick? Right now, I would probably say the X1 Carbon. It is just, I mean, don't get me wrong, I love the RatRig a lot as well. The X1 Carbon, in my opinion, is just a rock solid printer, and it's the closest thing we have to just print, you know, click and go, right? And I think that in the afterlife, I just want print, you know, click and go. I don't want to have to tinker. I don't want to have to play around. I just want click and go. So I'm trying to line this up at the top, along the top edge with my 1, 2, 3 block, and then using the other one to keep it square. And like I said, I'm just going to lock one of these down. I mean, I'm using a 1, 2, 3 block. It should be nice and square. I like using my fingers just to double check. Still there, Shrimp Father? Well, thank you. Yeah, I mean, I love my other printers. Don't get me wrong. There's other printers that I won't get rid of because I love them that much, whether I'm printing with them all the time or not. You know, each one has some type of sentimentality to me because I built every single one of them. Right? That's the hardest part of selling them is, or you know, selling them, giving them away is because I built them. Right? Now I am going to be selling some of my printers just because I need to, one, make room, and two, make finances for other builds. But yeah. Yeah, and as you see, we do have affiliate links for West 3D, KB 3D. We've got links for Vision Miner, Polymaker affiliate links. So if you need stuff for your printers, please feel free to use my affiliate link. It changes nothing for the price for you, but it adds something to me, for me. It allows me to get things for the channel, whether they're upgrades or new printer builds or printer chow, you know, maintenance parts, what have you. It's all good. Also, the West 3D there, if you use Digital Dragon, the link west3d.com/digitaldragon72, that will, or yeah, Digital Dragon, I thought it was 72, maybe it's just Digital Dragon. That gets you to the affiliate page, and it links out so that I get recognition that you click there from my stream. And if you use the code Digital Dragon 72 at checkout, you'll get 5% off of your first order. So make it count. Okay, now these are in there. I'm going to go through and apply a little bit of Ugga Dugga to these. Are these fully torqued? Probably not. Do I want to use recommended torque specs for this? Probably not either, because once again, these are T-nuts on the aluminum, or hammerhead T-nuts on the aluminum extrusion. You will deform the aluminum extrusion if you torque these to the appropriate setting, I'll say, per spec. You would damage the underlying aluminum extrusion. And this last rear one, I'm not gonna tighten down Ugga Dugga anymore, because that one's going to get the bottom of the corner bracket piece. Okay. So now we've got those pieces in. The next pieces, whoops, turn this around. Play with my, so the next pieces here are going to be the shorter 120 pieces. Okay, these are the 120 millimeter pieces right here. I hide the one side. You'll see that they're going in there like that. So the reason we did it the way we did it is I'm now going to populate the two pieces right here. We're going to stand up one edge. That way I can make sure it's flat. I'll tighten these down, snug them. We'll do the other side, get those added on there, and then we'll tighten everything down together. And that should give us our laid out piece. So we've got 2 more extrusions, which are going to be oily nasty, just like the last one. So let me get these opened up. Actually, these aren't as bad. Yeah, very little on this one. I think that was just more of catching it from one of the other pieces more than anything else. Where's the end? There we go. This one had a little bit more of the shipping gunk on it. Rub off what we can, and then we'll wipe them all down with some more alcohol. And even though there's only, like a couple of top pieces, all of these have been tapped. So even though we're not using all of the tapped corners, they're all pre-tapped and ready for us. So that's pretty cool. Let me go ahead and get my screws laid out for these. Set up, I should say. Yeah, I've been pretty happy with the bamboo. And like I said, it just works. It just goes. right? So that's the best thing that I think that we can have right now is, you know, a printer that is very darn close to a an appliance, right? Do I have printers that can print just as cleanly? Yes. I'd really like a bamboo with a larger build volume, which I think is in the works. So I'm just curious to see what their cost is going to be on that at the end of the day. Because like I said, I'm going to have some projects that will require some larger build volumes. Is it going to be a daily thing? No. But I think if I show off a couple of projects, it may get me some more stuff down the road. Yeah, I know they were talking about Q1 FY25. How can I put this? I'll believe it when I see it. Not that I don't have any doubts that they can deliver. I'm not sure how much the litigation set them back. Especially since that new machine build is going to be focusing at the prosumer market space, which is prosumer, non-necessarily you and me consumer space. And that is going to be a space where Stratasys is really going to take offense to them trying to jump in and play in their pond. Okay. So once again, I think we're going to start with this side up first. Slide that down. Slide this one down. Turn that around. That's going to keep, with the weight, is going to keep everything compressed down. We use our, I believe this is 1/4 inch. I'm just going to snug these up. All right, so that's one side. Now we're going to have to lay this down on the other, well, not lay it down, but line these up and slide the other side down. Like that. Tighten these up. And now that they're there, we'll set this down and we'll go ahead and tighten these down. Flip this over. Tighten this side down. So that's basically our Z-pillar. Now, we still need to get our corner brackets and the others ready to go. Me, is it I'm trying that way, this way. There's a piece that goes here, piece that goes here. Okay, understanding those. That. So there is a gap there. Looks good. Let's go ahead and we'll put the top piece on here. And I'm not sure if the overhead camera is working anymore or if it's coming back to life on us. We'll see. Yeah, we can put our top piece back on here, or not back on there, but on there. And there will be a couple of other pieces that we'll put in place. So this cutout goes on this back side where the gap is. So it'll lay on there right there. And this, once again, is where we're going to have 4 screws that go in. These will be our big countersunk screws. And these are M12 screws. Oh, I'm with you. I'm with you there, Pete. I have no love lost for Stratasys. Everything that they were going after bamboo for, they should have also been going, you know, against our favorite Uncle Joe for, as well as other companies. And I wasn't hearing them or seeing them go after them. So, yeah, I think I'm hoping that their lawsuit got thrown out as frivolous, but or no longer enforceable because they have not gone after people the whole time. So And I mean, let's be honest. The people that are using Stratasys machines are not the same people that Bamboo is targeting. Maybe with this X1E and the new stuff, but even still, you're not going to be printing the volume size of an X1E on a Stratasys. It just costs too much, right? You're going to use it for bigger machines. Okay, this part's going to kind of self-center. We don't want to crank way down on this because we can break our part. We're just going to make sure that everything's snugged up. We did put some Loctite on this. Hopefully I don't regret that for putting Loctite on it and then going through my ABS part here. But we'll see. So we've got the part at the top, and we'll lay this down. And you will note when I switch this around to the front side, that there is a plate along here. It appears to be a plate at the bottom of this side as well. So we'll have this, that is the plate that's down at the bottom. Right, so this is going to be the plate that comes down here at the bottom. And these grooves are going to sit over our MGN 15 rails. And the center is going to go over the lead screw for the Y-axis. Okay, so this is going to get mounted in here. These three screws, or these three holes are for M3 screws. Whoops. These three holes will be M3 screws that'll hold the plate for the bellows. Okay, now I don't see... I don't know, are these getting heat set inserts? We'll have to see over here on the other side. Take a look at our open view here. M3 screws. Oh, these M3 screws are for the metal plate that goes up there. These M3 screws, are these going into heat sets? Whoops. Yes, these are going into heat sets. All right. So we'll need to put some heat sets in this plate. Into these three holes here, we'll put in some heat sets. Let me grab my press. We'll bring it up here and we'll add some heat sets into that. This is probably going to get heat sets in it as well. So we'll get that prepped for putting in some heat sets. And where was our heat sets at? heat sets, heat sets over here. And 4, 5, 8, 6. Those seem like they're going to be too big. So you're seeing me jump back and forth in the CAD. Well, you maybe see back and forth in the CAD. Those are M3 by 6, so I need some M3 heat sets. So what I'm doing is jumping back and forth between CAD and the step file CAD and the CAD on their build site, so to speak. That's what I'm looking for. Because one I can explode and the other I can't explode. I can just hide a bunch of stuff. And it's really easier to explode things out to try and see what's embedded in what. Or like the thrust washer bearing layout type thing. So 3 in one, 2 in the other. The 2 that I'm referring to are up here. So there's going to be a plate that goes here that holds that end stop. There's going to be 2 holes right here that are most likely going to get our M3 or M4. It actually might be M4. They don't look like they're M3s. They look like they're M4s. No, M3s go in them. Oh no, we'll see. We'll double check here in a second. It's an M3 by 16, so that's going to be an M3. So all of these are getting M3 nuts or heat sets. We'll get this raring to go. And the ones that are going down on this plate here are going to be to hold the bellows. They're going to hold the bellows. And bellows are going to be like the accordion covers that will cover up and protect the lead screw from getting a bunch of metal crap in it. That's what we mean when we say bellows. Not hot enough. Hey, for Heathen. Oh, thanks for Heathen. You have a good one. And are you getting ready to jump on your own stream? Is that what you're getting ready to do? Or are you guys taking off and going and doing stuff today? Okay. Well, you have a
great and glorious day. And if you're on, maybe I'll jump on and check out your stream a little bit later. Okay. So those are done. Get the hot thing out of the way. So once again, this one's going to go up in here. Looks like we're going to use standard bolts. These will be the M12 by 25. The Big Daddies here. Once again, possibly not fully necessary to Loctite these, but I'm going to Loctite everything. Just makes best sense. Make sure to get it the right way. And I won't be able to tighten these in all the way because once again, I don't have the right size wrench to get in there. So I'm just kind of doing it as far as I can with my fingers, and then we'll be stuck until I go to Harbor Freight or something and can get a wrench that I can wrench on these with. So these will have to be tightened up a little bit later. Now there is a plate that goes here, and I do have a plate that I was trying to figure out what it was, and hey, this is the shield panel. So this will be to prevent crud from getting on any of the electronics or the upright lead screw for this one. So just a basic panel. Doesn't have to be anything big.
And all it's doing is closing this large gap up here. It looks like it goes all the way up at the top. Down to the bottom like this. And then this piece will mount right underneath it. So this goes on with M3 by, is it 16? M3 by 12. So M3 by 12. Okay, so there's our M3 by 12s. We'll need some of the 440 M3 T-nuts. And this feels like a really, really, really thin steel panel here. So we're not going to crank down on this at all. We're just going to get it in place. Again, it's a shield panel. We're not going to put Loctite on it just so it doesn't squeal loose on us. Because I am sure a small metal bracket can make a racket when it's attached to a piece that's going to be vibrating from a spindle. So go ahead and get Loctite on this as well. Okay, that goes all the way in. These are M3s, so we should be able to use our standard driver finally. And once again, we don't want to yank on this too much because if we do, we will bend this steel. Kind of makes me wonder why we're not using a washer under this head to distribute some more of the force. That's now on there. And then these are going to get, these were, what were these? M 8 by 16s. 25, 25. M8 by 20. M8 16s. Oh wait, these are the ones we've been using. So we'll need these. It does not look like there is a washer. So we're just going to go no washer, M8 by 16. Once again, we'll put a little bit of Loctite on that thread. Probably should have put it through the part first. Put it through the part, put a little bit of Loctite on the thread. And a hammerhead nut. Same thing on the other side. Hey, Papa Bear Yellnats, how's it going? Hope you are doing well today. I know I am doing pretty good. We are over here working on our whatchamacallit build. This is the RatRig Mill. Now I'm just getting these in place. They may have to be adjusted up or down some once we go to put this in place on the actual Z-axis. Now, one other thing I do want to do to get these last ones in place. Ah, yes, we can't, ooh, damn. Yay, this is going to be fun. So we're going to set this on its side. And the fun part's going to come here in a second because I have no way of sliding in the T-nuts other than kind of setting this in its place, sliding in T-nuts. What am I hitting on? Yeah, darn it, this is going to be fun. Okay, so the printed part is a tight fit. There we go. There we go. So now the fun part is, can we slide our T-nuts in there and push them down into place? The answer will be yes. However, I need something long that I can push them down in there with. I don't want to go sliding this fore and aft because it will then damage the side of the extrusions. I'm going to move this all the way forward. And what am I going to use that's not magnetic? ETFE tube. That's at least down in the right spot. And close. So because this corner side here is going to use the corner brackets, let me get the other three in place first, and then we'll play with that corner. I think that's going to be the way to go. Oh yeah, no kidding. After all these things, most definitely, Chewy. All right, so there's one there. Let me see if I can get it to thread. Score! We got one. This one. So the problem that I'm trying to think about in my brain is I've got one of these so the bottom is going horizontal, the other one's going vertical. So as soon as I undo this bolt up here at the top, it's going to fall down. So I have to have it laid over on its side so it doesn't move when I at least put the foot corner bracket on to at least get them started. And then my thought is to set them back down here so they'll be flat on the work surface. But before I do that, I want to get the other 3 of the 4 bolts done before I flip this over on its side. So there's 2. And once again, sorry that my angles kind of suck at the moment. I promise you I'll show you what I'm doing in just a second.
Okay. Now I got to lay this down at a little bit of an angle to get this build plate off so that I can lay this flat. And over on its side. Now, we've got these three in. This one is sort of lined up. Make sure that it's fully lined up there. Now, I need to get the angled foot bracket. I also need to make sure that, yes, those look like be the same size. So this, a little bit of Loctite. And it doesn't have enough length to get to that bolt. So let me see. I can pull said bolt forward with the magnetic. Hallelujah. I got it started. Now we're going to lay it back over because I need to take this bolt out, hopefully leaving that hammerhead in the same position without it moving. Rotating this around, bring this back in. It just slid. Damn it. So I think I'm going to have to get the feet on first and then slide it in from one side, but that means decoupling that. There's no easy way to do this. Because that backing plate is there, I would have to take the motor off, slide this in from the back side, which means at the very least, undoing the coupler on the lead screw. So I have to undo the coupler on the lead screw, undo the motor, or no, I don't need to undo the motor. I just need to undo the coupler on the lead screw. Undo the 3 bolts on the plate, which were just hand tightened, I think. Maybe they weren't. Yeah, those would have had to have been hand tightened.
and hand tightened with a little bit of Loctite, so now I cannot unhand tighten them. God dang it. I take the motor off, I take the thrust bearing off, I take the back plate off, I get these set up with the feet pre-positioned on them, slide it on from the back, then tighten everything down. That's what I'm going to wind up having to do here because the bolts aren't long enough to hold this in place. Well, let me think. Guess the other option would have been to basically build the sides on the base. Thrust bearing. Now, let's see if we can get these come loose. Like I said, these were only hand tightened on here, so not a lot of force, but definitely not torqued down on this plate either. Kind of what I'm doing here. I'm taking these 3 really big bolts out. Taking this back plate off, which will allow me to slide this back off the back, dropping some nuts along the way. Oh, catching on the lock nut. So let me, oh, damn it, that's going to be, these 2 right here, they're screwing me now, so this one. Okay, so we need to set up all of these and our corner bracket here. Damn. I have to come in from underneath. Luke. Get that off. Where are the other ones that I dropped? Where'd they go? Where'd they go? Where'd they go? They bounced around here somewhere. We'll find them later. Okay, so I'm gonna have to take this one off using gravity as my friend to keep the T-nut in the right spot. Because once again, the issue is the bolts aren't long enough to go through the bracket and then into the T-nut with gravity. So I'm basically going to have to get these started using gravity as my friend. That way, that one through and get this don't think the bottom one gets a washer, because then I think if we do put a washer on it, it's still too short. Doesn't make sense, but anyhow. These up. Sorry, I know I'm talking to myself. I'm trying to, once again, there's no real manual for these. So I'm trying to figure out order of operations as I go through this. And part of what I'm having to do is no, that's a different build. Am I? Okay, now I gotta think through something. What am I missing? Another one of these. Goes through here, goes in there, but I think I'm down a couple. Are these different size bolts? M3 by 18, which is ones that we've been using the whole time. Not M3 by 18, but M8 by 18. The washer on those seem to be. So that would help. Need to flip this over. Need to find the two ones that dropped and bounced. I don't think I grabbed off the floor. Where did they bounce to? Did I grab the two that hit the floor? I don't remember grabbing them. Hopefully I'm not. Should be good here. Ones went in the end. Okay. Am I out of screws now? I appear to be out of screws. These last two are the same as all the others. M8 by 18. M8 by 20s are going into
these. So these are M8 by 20s, a little bit longer. That might have been the issue. That would have helped. Definitely would be longer. That makes more sense. This would go up here at the top. This location. This one, which is also M8 by 18. Go up here. M8 by 20. Goes through the leg. Yeah, this is, we're going to refer to this as the metric butt ton, because that's about what it's going to feel like. This one's going to come up here. Okay. An M8 by 20 with no washer. Come back up through this one. Go into that. Okay. So I think we're on a roll now. Get the right size screw in the right spot and things work out a little bit better apparently. Now we need to get one of these in there and pushed into the right spot. And look at that, it was long enough to grab hold of it. Okay. So I think we're back to square one again. We're gonna try and line these up and slide them forward along each edge. Come on now. What's this hell? That one's good. Yay. That's on. That's on. Those are going to be flush. I need my rear plate here. somehow bearing and washer at this end seems to have to not be properly aligned anymore. What am I trying to do? Take these in, finger tight. I'm going to, that's not going to scoot down anymore because I'm right up against the rails. What do I need? There we go. Got the bearing pushed back in there. These are still going to need to be torqued. I am just giving them a little bit of a little squish tightened. Definitely will want those to be properly torqued though. Okay. We've got that on. Now we're going to take and put our motor mount back on here. And making sure that we're lining up our, cross bearing first. Then lining up our rod. Half no, or yes. Get our motor lined up, start screwing that back in. All four corners. And once again, none of these bottom sets of bolts are screwed in just yet. So we're going to take care of that now. We're going to turn this sideways once again so we're nice and flat on our deck panel here. And we're all the way back. Go ahead and just start setting these in place. Just making sure to show a little bit of love to these. Again, we don't want to crank them too much and deform our aluminum. Well, so here's some of the initial comparison.
The Milo is built using 30 series extrusion. This is built using 40 series extrusion. Okay, so that's the first point of comparison. This is going to be chunky and heavy. We don't have any additional weight added to this yet. Like we haven't done any, whatchamacallit, like epoxy granite or anything like that. I don't plan on doing anything like that. I know there are people that will say that that is sacrilege. You have to put epoxy granite and fill in these extrusions, add whatever, you know, ballast to this to make it even heavier. It's a heavy machine already, right? This piece will go right there. Tighten these up. Okay, so once again, this covers, so this is pushed all the way forward to the ends of the MGN rails. This comes down and covers those rails and the lead screw. And these 3 screws here is where the bellows are going to attach. There will be bellows at the back and the front of the machine that will accordion in and out and keep the rails and the lead screw from getting stuff all in them. Now the next thing we need to do is we'll move this back. Oh yeah. We're turning the screw and we're not turning the motor because I forgot to tighten the clamp back on the lead screw. So let me do that. And then make sure that when I move the handle, it moves the motor in the back, which it is now. And the reason I'm doing this is I need to add the feet to the front. So we'll do that. We'll add the Y back in. And we'll have our foot in the front here. That's the one. M8 by 16. M8 by 16 on each side. M3. M8 by 25. M8 by 16. Come on now. Hey, Jabrawabadabas, welcome in. So yeah, like I said, the comparison to the Milo, this is definitely going to be a lot heftier of a machine than the Milo. Yeah, a lot heftier. It's going to be, I think comparatively wise, like God, English sometimes. The Milo I built with a 1.5 kilowatt spindle. This I'm getting a 2.2 kilowatt spindle, and I think this one will live up to that spindle a lot better than the Milo would, just because it's going to be so much more rigid. This is going to slide in. It's going to be right up to the front like the other side, and we'll put the bottom feet in a minute and get this up on its own 2 feet, or I should say its own 4 feet. And I've been putting Loctite on everything because, well, it's going to need it. A 1.2 kilowatt spindle, this thing will be able to get up and boogie. So by putting the feet on the way I did, they are now all nice and flat with the 4 corners of the extrusion. And there we go. So now when I go to put the feet on, we should be good for M8. Drop in T-nuts. I throw the bag for the washers away. Those were M12 simple black washers. I may have. Give me 1 second to dig around in here. Screw. Half-head screw. I don't think I did. Oh, hell, I don't know. Oh, wait, there they are. Okay. So this is where we're at right now. How do the feet themselves go on? Go over here to our exploded view. So lock nut. Yes, it looks like a lock nut. These are most likely M5s. What do I do with the feet? Nope, those would be like M8s. Bellows, got what else? Big boys. M8 by 30. Okay, so those are going to go there. I need M8 locking nuts. M8 locking nuts.
Darn it. Now, I don't know how the hell we're supposed to hold these to get the... How would you even get in there to hold those? Not getting nitpicks, and I'm not getting standard pliers in there. Any thoughts on how to hold a locking nut in a channel like that? Lock these. Yeah, deep well socket's about the only thing I can think of. But I don't know if I have a socket that is that big. And a crescent wrench isn't getting in there from the side either. My nitpicks are probably going to be too big. Even coming down from, yep, can't come down from the top. Even if I do it at some type of angle to start with. Yeah, you definitely have to, yeah, deep wall socket is about the only thing that I can think of, but the head of that bolt's also going to get in the way of doing a deep wall socket. Can't get in this way. Can't get in that way. I mean, I might have to use needle nose. I think that's going to be it. The needle nose to the right location of rotation will kind of lock it in and allow me to thread the knob.
so to speak. So we'll do that. With the first two done, and then we'll slip the other feet off and we'll do the back one. And I believe on the back, we're looking for the outer edge, not the inner edge. Yep, outer side. So let me turn this around. Put it like that. We're going to go on the outer edge here. Will bugger paint though? Yeah, I don't want to bugger the paint. Don't want to bugger the paint any more than I have to. Darn it. I know somebody's somewhere is going to watch this and say, don't you have sockets? Because I've gotten that on my YouTube feed. I also got yelled at about doing some of this and was it pushing the ECAS fittings in. Not going to be good for carpal tunnel. And I'm like, yep, I agree. Not going to be good for my carpal tunnel. Well, yeah, and Milo, because I just saw that comment, job per Wabasada, Wabadabos. Yeah, Milo is modifiable. Darn you. It is modifiable. People are modifying them. And it's designed to be that way. I mean, you can modify this as well if you want. That's the nice thing is it's open source. And you can modify things to your heart's content. Right? I wonder if I can probably get into this from the side here a bit better. Yeah, that works. I have more room on these bigger ones. Oh, and by the way, if you put this in the enclosure, just like the Milo, if you put it in the enclosure, you're going to take the feet back off and you're going to bolt it directly to the enclosure. So, yay. So, how are we doing? Well, we're going to set this down here real fast. Move this out of the way. I'm going to grab this one. We're going to put a little bit of IPA on here. Wipe this down to get all the crap off of it from what the build's been so far. A lot of shipping grease and oil and stuff. We wanted to get off there. Right. That's out of there. Now I'll bring this back up. Boom. Here's where we're at so far. We've got our Y-axis in. It's being driven. It does drive the motor now that I redid the clamp in the back. We've got our Z-axis all in.
everything is tightened up. None of it's torqued down yet, so to speak. So I do need to get the torque wrench, find the right torque values, and torque the metal plates that are going into the extrusions, get torqued. I don't want to torque these. If I try and torque these down using the hammerhead T-nuts, I am going to stand a chance of bending this aluminum extrusion. Now you look at the extrusions and you go, really? That's some pretty thick aluminum. I don't want to take the chance, right? Oh yeah, lubricant systems are already out there for Milo, both misting and full, I was going to say wet or flood lubricant. There we go. And I can see the same thing for this. I can really see the same thing being for this. Okay, so where are we at today? Well, we are trying to figure out scrolling and maximizing on scrolling and maximizing over here on Fusion 360. So this is about where we're at. We didn't add our little knob on the front here. I did find there was a couple of more spacers over here. So I'm assuming that the 35 millimeter aluminum spacers here are probably the ones for the jog wheels. I don't want to put these on because that's another thing that I can catch and break off. We'll hold off on doing these until a little bit later. But we will add our little jog knob or jog handle there. We can also add in a good portion of this. So this is the other top plate that's going to go on here. We have not installed that as of yet. What we're going to do okay, so we should be back. Kind of weird that that one died before that one did, but we should be back and live now. Okay, so we've got the Y, we've got the Z, the X plate. Once again, we've got all of the countersink pieces right here. We're going to mount this on, we're going to mount the rails on the X-axis. We're going to mount this plate to those rails, make sure that we're good. We're going to do everything like we just did with the Y-axis. And then this part here is no longer going to be accessible to us. That's why we need to make sure that our lead screw's in place and good. And it's going to sit down just like that. We'll have some through bolts. Now, it looks like there might be a little bit of adjustment here if we need to square up some skew. But that's how these two plates go together.
Yep, we're back. So there's going to be 4 through bolts here that are, let's see, M8 by 25s, and there will be locking nuts underneath those, and that's what's going to hold the 2 axes together, X and Y. We haven't installed any of the end stops or anything yet. We haven't done any of the electronics. We're just doing the physical setup. So on the next stream, when we come back, we'll be building the X axes. So we'll leave the rest of the machine down on the ground. We'll build the X axes. Then we'll bring the machine up. We'll mount the 2 together. Actually, we'll probably leave the X off until we get our Z built. So we'll build the Z stuff. That may be built off the machine as well. Because I think we'd be able to do the Z-axis off the machine as well. So we'll probably do the X-axis, then we'll build the Z-axis, and then we'll come through and join those 2 axes together on here, and we'll start getting stuff put together. So if we hide that stuff, we just bring in that's the 1 plate assembly, and then there's the Z-axis. So the build plate that's going to get mounted here is physical mounted here with the rails, and then we're going to have the carriages go on here, the rails go on the front longer piece, and the rails will move up and down with that motor. And then the X-axis is the long deck here that we'll build, which is the 180. I'm sorry, 160, the 40 by 160. So we'll come back, we'll build X, we'll set that aside, we'll build Z. Once we get the Z stuff done, then we'll come and mount everything up and get everything mounted and running. Or not mounted and running, but mounted and good to go. I'm going to check and see where we're at on electronics, and we'll wire up as much of the electronics as we can to try that out. But at this point, I'm going to say this is where we're at. My hands are a bloody mess, but provided this will release, for those of you wondering and asking what our prints look like and the print tolerance. So bottom layer. These are pretty decent steep overhangs. Little jags here and there, but not a lot. I fully expect this to be working just well. I'm going to do a filament swap, and I'll print the other side of this. I believe this is the traffic cone one, but this is the one that you'll sit it on top and it'll spin its way down. So it's the spiralized fidget toy. My brother was interested in one of these and asked me about it, so I'm printing this for him. And he'll be able to take that to work and have fun with that at work. So, yeah, that's kind of where we're at. The plan at this point, as always, Tuesdays and Thursdays we will be streaming. I might stream more this week because I am off this week. So if time is right, you may see some extra streams going on where we'll be working more on this, trying to get this assembled. This is not a, this should not be taken as true build videos. This is a beta kit, right? We're building this beta on stream. because it's an open beta. If it was a closed beta, it wouldn't even be done on stream unless I had express permission from RatRig to do so. So this is under open beta. I've paid for this. We are building this. And I think so far it's been fun. We're kind of thinking, orders of operation and what has to be done, how to get things assembled before we do this, that, and the other. That's kind of been the fun so far of trying to get this done. Had I realized that these were 820s on the back, I think we would have been fine doing it the way I was doing it beforehand, getting the top piece in here without having to take the motor and stuff back off. But we're good. Everything is still moving nicely. We have no backlash to say. So now we just need to do that for the rest of the axes and we'll be good to go. So with that being said, we are going to find a good target to raid out to today. And when we come back, we will get started on the x-axis. Thank you everybody for being here today and hanging out. I know it's a short week for a lot of people. Some people had to go back to work and stuff, some don't. So I really thank everybody for being here. And let me see what we got for potential raid targets. For the days up, Jerry 3DHP's up, Free Heathen, Sid Heresy, Night Crafter, Stephen Poole, Only Dan, Brillo. We normally jump into the Free Heathen, but we haven't been over to Jerry for a little bit. Looks like he's got a full house today, so let's jump over to Jerry 3DHP. And folks, thank you once again for being here. I really do appreciate you guys taking your time and hanging out with me on Saturdays. We've got a lot coming to the channel to include some rebranding. We're going to go live on YouTube going in FY25 and everything else. So thank you all for being here and just spending your time with me and going on this learning journey with me. Right? I learn just as much as you do doing every one of these builds, especially builds like this where we have no script, we have no manual, right? We're winging it. So this is me applying my knowledge, looking at CAD and trying to figure it all out. So thanks for going on this journey with me, everybody. And I will see you guys next time. Should be Tuesday at least, might be sooner. We'll see. I just keep an eye out for notifications. Thanks everybody and have a great one. Bye now. And for those of you that are still here on YouTube and have watched all the way to the end, like I said, there will be some YouTube only content coming up in FY25 as we continue to grow this channel and my business. So if you've stuck around this long, like and subscribe and be sure to hit the bell as well so you get notified of new streams. And right over here should be another YouTube algorithm decided linked video. Thank you all for being here and have a great day. Bye.